Okay, I can see only 12 people right now. Okay, we will start in next 2 minutes. It's not even half the class.
I will just check with Mahesh and Girish, Shivank.
Sure. Okay, I can still see a lot of people are missing, but probably we can start now because today we have a lot of topics to cover and there are a lot many things to go on. Maybe Lakshmi, meanwhile, if we can check because today class is going to be important from Apache Kafka point of view. Okay, so to start with, what all we have discussed in yesterday's session. So in yesterday's session, we were mainly be spending time understanding the Spark streaming concept. And we have started on Spark MLF. That was the second point which we have started. Now in today's session, I'm going to very quickly walk you through on Spark MLF. It's hardly going to take maybe uh, 20 minutes or so. I'm not going to devote more time to that because we have to quickly come to Kafka. Now, after that, next time we will be spending completely on Kafka. In Kafka also, there will be few topics which we will be discussing. Number one, first we will talk about basic Kafka, how we create producer, consumer, how to run a code with that. Very basic level of the things what we will be starting with. Going further, then I will be talking about Kafka Connect. Basically how to create a pipeline simply and can work with that. That is basically going to be as a part of your Kafka Connect.
So we
So
can
in
see
this,
your screen show, writing something.
yes, I was typing. You can see it now.
Yeah.
Okay. So then we will be moving towards Kafka Connect. That's our second topic, which we will be going with. So these are the things which we will be finishing up today. As today is the last session, there will be. I was even thinking of giving you a case study in Kafka, but given that this Kafka is so basic right now that there cannot be any case study which can be derived out of it. Though I can still give you a few cases, but one of the very small case study I will be covering it in the class itself, which is more related to Kafka Connect. So that how you create that pipeline, basically bringing a data. But other than that, for if you ask me on a personal note, which I do it in my own experience, I do write a lot of code in Java. to work basically with respect to Kafka, which is currently, since we are not covering up, and Apache Kafka is mainly Java driven. Even if you want to, let's say, create a connection from your Spark streaming to Kafka, again, you need a Java, because we have that Kafka basically API, which we use it to kind of create the connection, and that's how your Kafka streams simply connects to it. I will also introduce you a bit like what is Kafka stream, where to use what, those topics I will be bringing up. But again, that's a separate thing to talk about. Now, let's start very quickly on Spark MLAP. Like I said, I'm going to hardly spend some 15-20 minutes on it to just give you a quick idea on this, and let's move to Kafka. To I'm kind of going with an assumption right now that all of you are well aware of basically this, what is regression classification. Now I've given you yesterday some heads up, like what is a supervised learning, what is the unsupervised learning. So in supervised learning we have regression and classification. So in regression we try to get the output in a numerical real number format. For example, if I say salary prediction, so that salary prediction is, could be, let's say 10,000, 10,000 maybe per month. It could be 10,000.02 per month. So there is no range for it. It could go infinite. On the other hand, classifications are like you have fixed outputs. It could be like a yes or no. It could be like 0 or 1. It could be maybe you are given some 5 outputs. For example, if I talk about Gmail, then Gmail could have spam, non-spam. Then you could also have even the things like, for example, personal, social, promotional, right? So now you have 5 entities, but again, that's a classification problem. Now, first thing when you work in machine learning, you do some sort of data transformation for it. Now, when it comes to data transformation, I have also given you a few links here. So since I will be giving you this notebook, we can walk through it in detail later. Here also you can see first thing first, we will be creating a Spark session. And I'm using Python here because I believe all of you who are data scientists, you all must be working on Python. Am I correct on that? If you guys can quickly confirm.
Yes, Shivan.
Yes.
So first thing first, you will be creating a Spark session then. Now using that Spark session, you need to create this Spark object, right? Which is going to be a Spark session object. Now, when we were connecting with Spark Shell, this was automatic, or PySpark, it was automatically available to us, but here we need to create it. So we will say Spark session.builder.appname.get or create. Now, this app name could be anything. You can give your own name also. It's more easy when you go to Spark UI and would like to see that. And then get or create, basically, if it's already there, then take the same thing. Otherwise, create a new one. Now, what I'm doing here is I'm using a data which is called as fake_customer.csv, because here I just want to quickly show you how the data transformation looks like. And I'm also saying infer schema as true, header as true. This we are well aware of. We have spent a lot of time on it. So this is how my data looks like. Now, let's say, like you all know, right? In machine learning, people who are well aware of, we have something called as one-hot encoder techniques, right? Where to the string objects, we give something like 0, 1. People who do not know probably all this, it will be just a very quick run. So you can ignore that. This is mainly for people who know ML. So I'm kind of going with that assumption. So here, basically what I'm going to do is I'm going to create quickly some data. So I'm going to create a data frame having one numeric and one string. And basically that is going to be denoted as user ID and category. You can see this is how also I can create it. And the one important thing which I'm doing here is I'm using something called a string indexer. Now using this, what I'm doing, look at this string indexer. String indexer, what it will do, it will give some numeric value to it. For example, if let's say it's A, you can see A is given 0. Similarly, here also A, so it's 0. Here A is 0. B is given 2. There is no other B. That's the reason it's only 1, 2, and so on, right? So a string indexer is going to just assign some numeric value of it. So that is what we are doing, passing the category column. This is the one, and renaming it to category index. So you can, that's the reason you're seeing that it got added as a new column with the name category index, and we are just making it like that. I'm pretty sure all of you are coming from pandas background, scikit-learn. You must be well aware of what is going to be fit and transform method. I'm not going to explain that. So you can see even in your Spark MLA, you have all these things available. When you show that, you can see this output as well. Now let's see quickly vector indexer. This is going to be also important to understand. So when I talk about vector indexer, look at this, what's going to happen. For example, if you see here, I'm going to create a data frame. I'm passing all these values here. I'm saying this ID, mobile. This I'm calling it as user features. And I'm doing a data section show. This is the simple data frame which we have created. Now let's see what do you mean by vector assembler. If you look at this, what I'm doing in vector assembler, I am sort of combining few columns together. This is a requirement when you're working in your Spark ML. Basically, like when you work in your scikit-learn, you used to give it like x1, x2, x3 if they're independent columns. But here we have to combine them and make them into a list format. So for example, here you can see I'm going to say R, mobile, and user feature. These are the three columns. I'm going to combine them and call them as features. Look at this. So basically what happened, this 18.0, if you see it from here, 18.0 coming from here, 1.0, which is coming from mobile. Then after that, you have the 0.0 and so on. This is from user feature. And you can see these three things is what I have placed up here also, right? So what it have done, it have combined them all together under one column. Okay. And again, your dependent variable, which is let's say clicked, is going to be 1.0 itself. There is no difference in that. Now let me quickly show you maybe linear regression just to give you an idea how that looks like. So we just saw the data transformation techniques. One is string indexer, and second thing I just showed you is vector assembler. Now let's see how I'm going to use it to create some models. Again, I'm creating a session. I just quickly create this builder app name getter create, all good here. Now you can see here that I have basically created this linear regression object. And then within that, I'm going to create this CSV file, which is your e-commerce.customer.csv file. I'm doing the infer schema as true, header as true. We are well aware of that. Print schema, we already know. We can see all these data types and so on. We can also see this outputs, which is all good. Now look at this head dot, basically data dot head. So I have this all records. I have email, address, even avatar and so on, average session length, type on the app, time on the website, length of membership, yearly amount spent. Right? Maybe I want to predict something like yearly amount spent for this particular part. So that's something I can do as well. Now you can see what I'm going to do now to make it ready. First of all, I can see all the columns. Now you notice what I'm doing here. All my independent columns, I'm combining it together. Okay. Now, definitely in this example, since my intention was just to show you how Spark ML works, I have not done any data cleaning, data wrangling activities and all that. My focus was completely on to just to give you the API's perspective on a small case study. So here you can see this input column and I'm renaming it as features. And you can see I'm doing the transform for it. And this is now my features looks like, which is going to be all your independent column in a form of vector. So this part should be clear to all of you. We just basically created this. Now, what we did as a next step, you can see when this output, now see this part. Now what I'm doing, this feature, which is a vector of all the columns, and the predicted column, which I have to predict, like dependent column, which is a yearly amount spent. These two we have created as a final data. Now you can also see, just like in your scikit-learn, you can have the split for training and test data. Same thing I'm going to do it here, 70%, 30% split. You can change it as per your wish. But you can see all these functions are available here. Then you can do a describe and show. Again, just like in data science also, you do all this, right? You check your mean, median, standard deviations. You also look at your first quartile and so on, right? So same activities, you can easily do it here. Now, with this, you can infer something, but again, let's not spend time on that. Now let's see the linear regression. Now linear regression, what I want to do, I'm going to create this object. As you can see, this class which I'm using is specific to Spark ML. And now what you're doing is you're saying lr.fit and going to pass a train data, right? The 70% of the data. Now what happened is, as soon as I did that, now what it will give you, it will give you an intercept value, like you get this, right? Mx plus c. So you get m, which is a slope, c, which is the intercept, right? So you got all these values, which you can also see that. If you want to evaluate it on the test data, you can also do that. You can see all the residuals also showing up for you. This is a test result.residuals. Similar way, if you want to perform some more activities, you can also try that, right? So you can see this is your actual outputs. Basically, this is the features, and corresponding to that, this is the prediction, right? Even in your linear regression, people who know machine learning very well, you might be knowing we have something called as root mean squared error. You also have even R squared. That is also a function which is available. So everything you can get it here, adjusted R square, everything you can get it from here. So this is the way you will be sort of working on the linear regression part. Any question on this part? I know I was quick on this because the intention is just to give you the quick API idea. I have already ran it because sometimes running of this code also takes some time. So I've already run it beforehand so that it can be quick to show you. But any questions on this? People who do not know machine learning, you can please skip that because anyway, it will not be feasible to cover ML in short time. Okay, so let me go to quickly. Let me go back. Let's do the classification. This is a very famous problem, Titanic. I think people who have done machine learning must be well aware of it. I picked up the same problem. Again, the insight or the idea was to show you that how you can work on the Spark session side from the classification point of view, especially logistic regression. Now, in this case, what we are going to predict whether any person have survived or not, right? If I give the data set for a person, whether that person survived or not in that Titanic tragedy, what had happened. Now, in this case, I'm also going to create a quick Spark session. You can see I'm going to create an object. I'm again going to read this CSV file, do the print schema, look at all these columns. We can see all this select data. Now, remember we have learned about this na.drop because in this data, there are some missing records. Definitely, we have not done any analysis here, though we could have done that using Spark SQL things. I could have looked at the data, maybe do at some describe. Maybe I would have looked at it whether I should replace with mean, median, or should I drop? Like I could have taken a lot of calls based on some data analytics activity, but here I simply dropped it because I wanted to just create my model. Now, next thing is, now notice one thing which actually is important, which I wanted to bring it up. So here I'm going to use on the categorical data. Like for example, if I talk about the column sex, right? It have male and female, which is going to be your categorical data. Now, in this case, first I use a string indexer so that it can transform, let's say, male to 0, female to 1, and so on. Then I'm using one hot encoder. People who are coming from ML background, I'm assuming again you know all this, right? What is a one hot encoder? So one hot encoder will bring them into the column format, and that's what we are interested in, right? So it will just make basically male and female as a column itself and remove one column because otherwise we would like to avoid that multi-columnarity and so on. Now, I'm not going in that again. Now, embark is the from the place from where the person have boarded that ship. So this is about that. So again, I'm using the one hot encoder and string indexer for it. And I have given some names for them, right? So here I'm giving it a name as, after one hot encoder, I name it as sex vector. And here I'm naming it as embark vector. Now, here you can see I'm just, when I'm doing the vector assembler, means assembling all the input columns together, I just took all the important column names only, like passenger class, sex vector, age, sibling, PR, fare, embark vector, and so on, right? So these are the ones which we have. Now here, I'm going to import my logistic regression. And now I want to also show you, though I could have directly shown you the logistic regression, but the intention was to also show you how to create a pipeline using Spark ML, which you could have done it even in regression also. But just to give you that idea also. So here, what I'm doing is I'm creating this pipeline. So I created this logistic regression object also. Now notice what I'm going to do. I'm going to pass my gender indexer. You can note it here because when I hit this string indexer one hot encoder, I have nowhere done fit and transform. If you look at this, the reason was I want to pass them as a pipeline, like sequence of steps, right? In what sequence it should all execute. So I'm creating a pipeline. I'm saying that, okay, well, first it should create the string indexer. Similarly for embark, also create the string indexer. Then after that, do the one hot encoder on gender. then do the one hot encoder on Embark. After that, apply that vector assembler where I brought all the columns. And after that, execute this logistic regression, right? This object. So this is the sequence of steps which I have given it as a part of the pipeline so that we can very quickly create this object and go ahead with it. Now here, I'm again going to split it with 70-30%. Uh, this is all you must be aware of how to execute a pipeline. So it's the same thing like pipeline object dot fit. I give the train data to it. On the model which I got, I can quickly go ahead and transform it on the test data. And then I can do some evaluations. Like you can see here, I'm creating a binary classification evaluator, which is going to be with respect to, okay, this is the basically survive one. This is my prediction, which is coming out of it. And similarly, I can look at some other results also like AUC curve. You could have also got it like accuracy and all that. You must be well aware of those things. Right? Again, the intention is just to very quickly show you this. At the same time, you could have also done precision, recall, every metric you can create. Okay. It's just that I showed you a minimum. Any questions on this also? Clear? Perfect. Let's go to the next step. Clustering. Now, when I talk about clustering, in clustering, uh, this is going to be my unsupervised learning. You can see that I've taken the data from here. There are some notes you can walk through it. So I'm creating my Spark session here. I'm loading some data, seeds underscore dataset.csv. This is going to be head. This is going to be describe command. I'm quickly going to look at all my columns, what I have. I'm going to create it like a vector assembler. And then I want to also show you like when you generally go for k-means or clustering method, right? So you have to use the standard method, right? You have to scale your data. If they will not be in a right common scale, because all your k-means is dependent on a distance metric. And if one is very high, second is very low, one can dominate over other. This part again you're aware of, but I just want to show you the main point with Spark MLlib here. So in this case, I will be using something called a standard scaler. I can just pass my features. The output will be scale features and I will fit it. I will transform it. I will get the data into scale format. Further to that, you can have the k-means method where you are passing your scale features. You are telling here that how many number of Ks you want. Now you could have done hyperparameter tuning here to get that. But anyway, that's fine. I am just creating this model and passing this data set what I have using a fit method. Once I get that, now in clustering, people who know machine learning, you must be very well aware of, you have something called as within set sum of square error, right? Like in a cluster, what's the distance? If there are 2 points which are in two different clusters, what's the distance, right? So all those things you can get that because using this, you can also go and do some hyperparameter tuning for the K. But anyway, here we got some center points and these are the center points what we have got. We did some predictions like whether they will be sitting in which cluster. That's what we got. So let's say since we have created 3 clusters, that's the reason you are finding these 3 centroid points which you got. And you can see for every row now, like the first row is going to sit in cluster number 1. This number row is going to sit in cluster number 0 and so on, right? And similarly, this last row, which is 20th row, is sitting in cluster number 2. So like that, we got a mapping and we can take some business decisions out of it. That's something not to be talked about. But this is how, again, at a very high level, what we do as a part of Spark MLlib cluster. Clear, everyone? So this is it, which I wanted to talk from the Spark MLlib. Like I said, I will be very quick in just 15 minutes or so. I will finish this out, 15-20 minutes, because the idea was just to give you the API perspective of the things. Any questions on this before I move to Kafka, our main topic for today?
Yes, Shivank. Is there any, a different, kind of performance benefit of using maybe the Spark ML over maybe other ML libraries like sklearn and these things? Is there any difference, or is this simply, syntax based differences?
No. So number one, when you have a very big data, okay, especially let's say you have data setting into distributed system. Now on that data, if you want to do your analytics, is it feasible for you to do that by scikit-learn? No. Or using TensorFlow? No. So for those things, we have to think about Spark ML, number one. Second is if you have medium sized data. I'm not saying very big data, maybe a medium sized data. Even on those things, if you run it maybe by using scikit-learn and so on, it do takes more time in comparison to basically when you're creating models and when you do the online learning where you're continuously passing your feedbacks to correct that model and it keeps on improvising there. So that's where again Spark ML works better. For example, just to give you the insight, Google, when it comes to their Gmail platform, so they have a model running, right, which kind of predict whether this email should go to the spam or non-spam. And within non-spam also there are three categories like personal, social, promotional. Now, so that is a machine learning model which takes this call. Now that model also keep on improvising itself as well. That model they have created using Spark ML. That model which basically runs behind the Google. The definitely one reason is because the data is very huge for them, and at the same time, they basically needed a lot of things around that, and that's basically helps them in quick responses as well. So again, in those places, we go with Spark ML. Now, if you have a small size data, then go with your normal scikit-learn. That will be good enough to resolve your issues and all that. There is no problem within that. But medium sized data or the larger size data, which is sitting in distributed system, you can go with this. Now there is a challenge. When I say Hadoop 2.x, Hadoop 2.x don't support something like GPUs, right? So let's say if you have some deep learning algorithms like neural networks, which are like, or even if you want to perform something like word to vec, even they are available, but since the GPU support is not there in Hadoop 2.x, it don't build really well. But now with Hadoop 3.x, this came in. If you recall, yesterday I was talking about that there are few companies who started asking for it. So these are the ones where the use cases are getting derived at. So specifically now for deep learning, if you have ever worked with this TensorFlow, Keras and all that, you might be aware that especially when you do this convolution neural network or recurrent neural network, which is like very time series based, in those cases, the algorithm run takes a lot of time, right? Even on your normal machine, sometimes it can take a lot of time, even if you have not very huge data. Now, in those cases, your Spark will be very, very fast and give you very quick responses. So again, in those places, this is very helpful. Just to give you an idea, if since we're in Bangalore, I work for Fortis Hospital. So for Fortis Hospital, they were looking for a problem statement that they wanted to predict, especially when somebody get a tuberculosis disease. Now what happens is they take an X-ray, and what happens in that disease is that some water get filled up in your lungs. That is basically the problem which happens there. Now, in that case, what used to happen is, let's say you go for an X-ray report, then it used to go to radiologist. He do some checks, and it takes 3 days to get back the report. Now, for solving that problem, basically, what I did, I created a model for them, which is a deep learning model. And that deep learning model will be predicting within a minute that basically this person have tuberculosis or not. Definitely, I've used a lot of precision recall because it's related to your life in that scenario. But that model is running right now in Fortis, number one. Number two, that model which we have created, if you think about the input data set, that input data set is an image and a report. Okay, there are two different kind of things because image is an X-ray, which is not even RGB color. And second is a report corresponding to it, which is a text format. Okay, what's a summary of this? Now, the data set was huge when I created that model. What they gave was very, very huge. Now, the challenge was if you put that down, basically just using with the normal systems, it will take a lot of time. That's where we have again used Spark ML to get the help and fix this up. So it depends on your problem statement. So it's not like it's just syntax is. Syntax is, I would say, still not similar. It's about a business case where you want to think about that, what I should be using. Clear, Karthik?
Yes, yes, Shivank. So, in the codes you have shown us two, employ distributed systems, I guess there will be more changes in the code, like some data is sitting in one system, second system, third system, then accordingly we have to make some changes in the code also, right?
No, code will remain the same. So what you do is, see, few algorithms cannot be definitely distributed where it can work, right? So you have to bring the data using some part. It brings the data in some part and do it. But these algorithms are actually written in this way that they are going to work for distributed system and give you the accurate result for it. But code wise, there will be no change. It's the internal working, basically, which it transform and take care of all the distributed way of running that code for you.
Okay.
Just to give you example, just like when we learned about average, right? Now, if you recall in the average, if I would have taken the average on different systems separately and would have tried to take the average of all them together, it would have failed, right? Because that would have been wrong answer. So the logic what we applied there was that, okay, let's take the sum separately, let's count the total number of them separately and then do the computation, correct? Same way, even when you're working in distributed system, the way these algorithms are written, that it will ensure that you get the correct result, though, and it will be with a little different logic what you use for the scikit-learn.
Okay, I understand now.
Any other question, guys, on this before I move to Apache Kafka? Okay, perfect. Then let's move to our most awaited topic, Kafka. Now, when I say Kafka, what is the thing Kafka is going to do for us? Okay, let me just quickly open one thing. Allow me a minute. Okay, use it here itself. Okay, now what's the reason, in fact, also behind why Kafka came into picture? So number one, when we started working on the earlier systems, what was the challenge was that we have a client layer, business layer, right? And you have also a database layer, right? So that's how the traditional systems used to work with this three-layer system. And it was all great. I mean, there was no issue with that. But the challenge was that when you have to bring the data, let's say in a real time, it becomes a big problem. And a lot of times you have to go and even change your logics as well. It became very tricky to solve the problem. Now, what we will be doing here would be using Kafka, we have put down a transient layer embedded. So using that transient layer, we will be able to now resolve a lot of issues. So what I'm saying is, let's say even if I have a lot of sources, let's say this is my one source S1, this is another source S2, this is third source S3, and maybe this is my system where I want to collect the data. So let's say this is one, this is second, this is third, and so on. Now, in these cases, what happens if I have to create the connection between them? Think of it like a wired connection. So you will be sending it here, you will be connecting it with this, you will be connecting with this, right? Now, same way, you will be connecting this also with this, connecting this also with this, connecting this with this. Now, what is happening is you're creating a mesh kind of architecture, and that used to be actually earlier. This was the case earlier as well, but it was a wrong way. If you ask me, this was not a right way because it was very complex. And also not only this, even what you have to do there was a lot of times when you're working across with all these systems, you have to take care of all those network layers. For example, you have to take care of TCP protocol and all those stuffs as well. Yes, Harshal, you're saying something?
Shivang, what is the difference like Kafka and Confluent Kafka?
Kafka and
Confluent Kafka.
Just hold on. I have not yet introduced you with Kafka. Yeah, let me just talk about it. Then we can maybe bring up this. I'm right now just talking about the traditional systems. Yeah, I think Manju, you were also asking something.
No, sure.
Yeah. So here, what just happened is basically these TCP connections and all that network. Uh, can you mute yourself? Harshil? Okay. Now,
Harshal, can you go on mute? Harshal,
a lot of disturbance.
guys, anyone has Harshal contact number? Just call him now.
Yeah, I think by mistake we did that.
Yeah, sure. Yeah, we'll do.
Okay.
So that is becoming a problem and a bottleneck. Second architecture I just talked about was when you have this layers, right? When I said you have, let's say, client layer here, right? This is, let's say, your client layer. And in middle, what you used to have is, let's say, a web application. So here we used to have a web application. And then here you used to have some databases. So let's say this is one database, this is second database, and so on, right? So this is how my data was there. So the top one, you can think of it like a client layer. Middle one, you can think of it like a business layer. And the third one is your DB layer, right? So this is the way it used to be in the earlier stage. Now, if you think about it, they are very tightly integrated, right? All of these layers, like it have to request the data, it have to go through this, then it used to come here, right? And in fact, one more thing was there, it had very high latency also. Like if I have to retrieve the data or change something, the time frame was very big to do that. And at the same time, one of the biggest challenge as per me was that you cannot scale it very well. This was a big problem with this. Now, what LinkedIn did, LinkedIn is a company, right? So what LinkedIn did, they developed Kafka and they wanted to get some solutions out of it because they were dealing with this problem. They developed a thing, something called as Kafka, which is basically written using the Scala and Java programming language. And they came up with something called as a publisher subscriber model. So you have to publish, you have to subscribe, and some people also call it as producer consumer model also. It's just a way of talking it out, nothing much difference with that. And the idea was, can they develop something which could have a very lower latency when you have to send the data or when you have to retrieve the data. Secondly, when this problem, like having so many connections around, that was also not good. So how to resolve with this part? Now, all the problems which were there in this architecture, like talking about tight integration, talking about how to service setup, talking about latency, which is very high in this case, talking about how to scale the systems, if you are bringing the data in the real time, how to deal with that. And not only this, but the last, if I talk about even maintenance was very tough. I have worked across on these systems. I know the challenges what I used to face at that time. Now, what in this case Kafka did at a level, what they did, if let's say this is my basically layer, which was called as the business layer, or you can think of it, let's say, as a web application. So below that, they added something called as a transient layer. This new color is, you can think of it like a transient layer, or you can call it like a transient storage. Now this is in middle of the web application and your application, or maybe you can call it like a data tier, right? So that's where now what we will do in this transient layer, we would like to store the data in a temporary way. So we will not be basically storing the data for a longer time, but I would like to store the data in a temporary way. So what will happen due to this? This is going to help us in decoupling this architecture to transfer the data into the transient layer now. And because of this, we will be able to reduce a lot of latency, because earlier the latency was very high. I always have to hit DB, and DB processing do take some time. But because of this transient layer, I should be able to save some time across the time. That is going to be very helpful here, which we will be basically looking at. Now, in this case, we definitely don't want to do any data processing. So Kafka will not be meant for that as well, that we are going to do any sort of data processing and all, but we would definitely like to retrieve the data or to send the data very fast on these systems. Okay, that's one thing you have to keep in mind. Now, when we are talking about it, what could be the possible use cases also, what we can think of around this, right? Means when LinkedIn was developing it, what were the things they were keeping in mind? Definitely when you are getting the real stream data, right? So that's what was the major reasons what they were going with it. One of the things which actually I have seen these e-commerce companies using it a lot, or if not even just e-commerce, I know the case of Amazon, that's why I was talking the name, but even for other sites as well. So like what Amazon do when you visit their site, or maybe from web or mobile, what you do is you click multiple places, right? You say, you click on their three dots, you go to maybe from their some categories. In that categories, you maybe clicked on TV and so on. Maybe you have not bought anything, but you're just clicking to see some items maybe. Now, what is they are doing at the back? They are storing every click what you're doing on their website. This is called a click stream tracking. Okay. Now, the data which gets generated at every click is huge because you're not doing any transactions, but maybe every second you are clicking something and you're not the only user at that time. So at that places, Kafka is again very useful because since the data is coming at very fast pace to their platform, it's like they need a reliable system there to take care of it. Similarly, like logs data, which we also get, like especially if I again talk about Amazon. So Amazon, the events which happens on them is very huge. So the logs which keep getting generated for them is pretty huge. So again, to deal with that, Kafka is very well preferred in those scenarios as well to take care of it. All the log aggregations and everything is taken care by that. Even if you want to develop any messaging systems, like if you talk about WhatsApp, or if you talk about basically Telegram and all that, they all use this Kafka queue in middle to ensure that they deliver the data to you. So it makes the things very, very reliable for you in these cases. And that's the reason we have to use this. But it doesn't mean that you should start using Kafka everywhere. Okay. Uh, if your data, what you're getting is, let's say, is meant for more of a, you want to do some processing, right? Then don't think about Kafka. It's not meant for that, right? Even if you want to create, let's say, some streaming application, don't think to use end-to-end Kafka for that. Yeah, Kafka could be used just to bring the data, store it for you. But after that, for the processing component, you need to think about something else. It could be maybe the situation where you like to maybe use Spark streaming, connecting with that and doing the processing component on it. So that's where it's okay. Like even you have Kafka stream, but it's not that great to be used for all the processing. Kafka stream, I will even talk about at a very high level. It is mainly used just to transfer the data between one topic to another topic and so on. It's not basically for building some real-time applications and so on. So for those things, you have to think about either Storm or Spark streaming. I would suggest Spark streaming because that's far better with it. If even if you have, let's say the data, which is, let's say, like I said, if you want to migrate some data maybe from one system to another, again, it's not a very good use case for that. Though you can use it, but you could have done it with an easier way. You could have used something like I called as Flume also. Though we have not learned this, but Flume is a very simple way of even transferring your semi-structured sort of data as well. So that's, you need not even create all those clusters and all for that. So better not to use Kafka for all those things, right? Even if you want to keep your data for longer term, don't think about Kafka. Kafka is not meant for the longer term data kept as well. It is meant maybe just for a smaller tenure of the data so that you can keep it and do something on top of it and done with that. The data will go away after that sometime. That's the reason when I said transient layer, the transient layer basically means here that it's just for a temporary basis, some storage, what we want to do in this case. Now, any question till this point? I hope everyone is clear till this step. Clear? Okay. So that's the first step, what we just understood.
So Shivang,
about.
sorry, I was speaking on mute. So to handle this streaming data, like Kafka was the first tool, right? Like, was there anything? So was there something else also for? Because streaming data was there even before, right?
That's what I'm saying. Streaming
Mhm.
data, yes, that is for meant for, but it's not meant that you're doing streaming and then basically thinking of doing some processing on top of it within Kafka. So you cannot build application just by standalone Kafka.
Okay.
Yeah. So you can bring the data to some system and then use it. So I have seen people, what they do is they start thinking of using something like Kafka streams, and they think that, okay, I will be developing this application with that. It don't work in the long run. Never do that.
Okay, Shivank.
Yeah. Now, so we just understood about the first thing, how this Kafka sort of looks like and what are the things involved in it. Now, one more thing which I want to talk here is, so let's say if I talk about Kafka, so Kafka have its own cluster, number one. So let's say this is my cluster, right? Now in this cluster, I will have some nodes. So let's say this is my node 1. This is my node 2. This is my node 3. Okay, this is my node. Now, what happens is, in order to manage this cluster also, we need something. Otherwise, how you will be working across with this, how it will know where it is what. Just like in your big data systems, you have this name node, you have this resource manager. Similarly, if you want to work on Kafka, you need something called as Zookeeper. Without Zookeeper, you can't do anything. So Zookeeper, which I have drawn, is going to be on the green color right now. And in the Zookeeper also, we have various nodes. I will talk about Zookeeper in some more time. Basically, Zookeeper, you can think of it right now. It will help to manage all your nodes. It will have all the details where everything is, which machine is more free, less free, all the master activities it will. Secondly, so what happens is these nodes are all registered with these Zookeepers. Think of it like this. Again, just like name node have the registry of all the data nodes, right? Same way, this is just for your analogy. Think of it that every of these nodes will have their registry here. Okay, so that Zookeeper cluster sort of is aware of where is what. Now within Zookeeper also we have a model, something called as a leader and peers. So basically one machine act like a leader who take care of all the things, and if leader is down, then any peer can also become leader as well immediately. But leader is the one where generally the request goes, and based on that some action happens. Again, we will come back to it in some time. Now, so this is about the first thing which we have to keep in mind, that this Kafka cluster, as soon as I will think of, I have to immediately think about the Zookeeper. Okay. And right now, whatever I'm telling you is at a very high level, so that you get these insights slow by slow, and then you will be able to connect all the dots all together. Now, one more thing, what happens inside it, when you're working across with all your systems here, now what happens is in these nodes, let me go back to the same diagram itself. So in these nodes, we keep the data, right? So think about, let's say the data related to Twitter, I want to save it. So now in this, what will happen? I will have something just like in RDBMS. If I have to store some data, what I used to do, I used to create something called as tables. And inside those tables, I used to create columns and keep my data. Same way, in my Kafka, I will be keeping all this data into something called as topic. Okay. So let's say here I'm keeping a topic called as Twitter. Okay. So let's call it as Twitter. Yeah. So that's a topic for you. Now, inside this topic also, just like in Spark, if you recall, we used to have some partitions, right, to keep the data into an RDB format and so on. Similarly, here also, we will be having some partitions of these topics. For example, I could have P0 in the first slot, P1 in the second slot, and P2 in the third slot. And again, this topic could also be replicated. So maybe in node 2 also, I have the Twitter topic, and I have all these 3 partitions being stored here as well. Now, how this partition looks like and all, I will show you with a very nice example. For now, just understand it at a very high level, what is topic and what is partitions. So now here also, you have all this data getting stored in this particular case. So we understood right now that what is Kafka cluster. We understood right now that what exactly we do in form of basically putting all this data. Now, one more thing which also happens here is, so when this node have all this data around, so how it gets this topic? So let's say I have a Twitter application. Let's say I have this Twitter application. Let's say this is my Twitter application. Now in this Twitter application, what happens is there is a Java client. Okay. Think of it like a Java client. This Java client, I call it as publisher or producer. Okay. Number one. Now what it do here is this Java client will be helping me to send the data to Kafka cluster. So it is going to send the data to the Kafka cluster in this manner. Now, what will happen is that when the Twitter is also sending the data, it is highly possible that when I'm creating this topic, at that time itself, I will tell it that, okay, I need this many partitions. So now what it will do is for Twitter, it will create 3 partitions for me. So it will say, this is P0, this is P1, this is P2. Okay. Now, what's going to happen? Now, Twitter will be sending the data across to all these partitions. So now you can see that it's a parallel data which is getting floated through this Java application, which I'm calling it as producer or publisher. So now my data is going in this manner. So now all this will be working separately. So this P0 will be writing it now to my Twitter, which is basically my topic here in my P0 itself. P1 will also be responsible in the same way, and P2 will also be responsible in the same way. Okay. So now what I did, I just introduced now some more components for you. I introduced you with something called as producer right now. And then I introduced you with some partitions, but again, I have still not given you a full example of this, which I'm going to give you in a few minutes. Now, second thing is, so since I have already introduced you with producer, let me also introduce you with something called as consumer also, who is going to retrieve this data also. So my consumer is going to sit here, let's say. And what it will do, it will bring the data from this Kafka cluster like this, with whatever way it wants. So now here, maybe my consumer will also have maybe a P0 being arranged here. P1 will also be here. P2 will also be here. Okay. So like this, I will also be keeping my data, and basically I will be reading all these things from this part. So producer Java application is responsible for basically sending the data. Consumer is going to retrieve the data from that. That's the first step what we just understood. Now let's take an example to understand how this is all happening. Okay, to even understand how the data goes into partitions and so on. To go into that detail, let's see that. So let's see what's going to all happen in this case. Now, when I say topic, think of it just like a simple packet which contains some stream of data, right? And now that data, I'm dividing it into multiple partitions. That is what I'm doing in this case. Now, like I said, you can think of topic like just simple like a table. Let's say I have some tweets with me. Maybe my first tweet is, this is going to be, let's say, India won Asia Cup 2018. Let's say this is my first one. Now let's say my second one is, let me bring it here. Yeah. So let's say my second tweet is hash me too movement goes big in India. Okay. Let's say this is my second tweet, which I just stopped here. Okay. Now the third tweet is, let's say Cloudera and Hortonworks must. Okay, let's say this is my third tweet. Let's stop one more tweet. In fact, let me add a few more so that I can give you a better example here. Let's say the fourth tweet is maybe a person XYZ. I just wrote random thing now. He became maybe first woman to win Nobel Prize. Let's say this is my fourth tweet. which is going to be here. Now, let me add one more. Maybe there is some launch that's we are going to talk about. Maybe Google launches Excel. Maybe what's the latest version? I don't know. Maybe 3 Excel, right? I just wrote randomly. So basically, let's say Google launches something. And this is my 5th important tweet, which is coming maybe at a specific time. Then maybe I have, let me add 2 more quickly. Maybe I have, maybe ABC becomes India first Chief Justice. Just again, some random tweets I'm writing. Have no sense. Now, the same way, let's say if I have to talk about one more, maybe I can say there's one thing very famously was going on. India reaches to 75 USD. Something like that. Okay. Let's name it as 7. Oh, sorry. Okay, this is let's say 7. Now what's going to happen? So first thing what I will do, when I'm going to transfer this data, I'm going to create a topic. Maybe that topic name is going to become like, let me use any random name again. So let's say my topic name, I created it as top news headlines. Think of them like maybe latest tweet, which are running like that. And so, right. So that's the first thing. Now, how the data will go into this, right? Maybe I have created 3 partitions for this. Now, let me explain you how the partitions looks like. So when it will be partition, it basically means that there will be, it will name it like partition 0, partition 1, and partition 2. So maybe this first tweet, which is coming here, this, it will go maybe the partition P0. Okay, let's say this went to partition 0. If you look at the second one, right, which is let's say related to me too, maybe this went to my partition P1. Okay, let's say this, or okay, fine. Maybe I can say partition P0 only. That doesn't matter actually. Now, maybe this one, basically, if I take any one, let's say this one, maybe this went to partition P1. Okay, so it's a random choice how it is sent, though we can also do it programmatically that, okay, send this data to P0, send this type of data to P1. That is also feasible. When I will go to the code, I will show you also that how all these things happen. Maybe this is also going to partition P1. Okay, maybe this might have went to partition P2 like this. So what is happening? Randomly, these tweets are moving across somewhere. So let's say this have went to partition P2, and maybe this have went to partition P1. So it have sent basically these tweets. So now basically a logical entity of data will be going to a common partition. That's number 1. Now, second thing is, which is also important to understand here, even this data also goes into the partition in a form of an offset. Okay. Now, how we decide this offset? Let me first draw it in a separate diagram. Then I will come back to the same diagram and show you. So let's say for partition 0, so this is, let's say for partition 0, I will be getting some data, maybe a tweet within itself, which will go to a particular offset. So this will be there for P0, P1, and P2 all. Okay, and it will be like, okay, it will be like, let's say this is my 0th offset, this is my first offset, this is my second offset. It will go on in this manner, right? Now, similarly for partition 1 also, I will have some offset. Maybe for partition 1, I got some 7 offsets. Maybe for partition 0, I got maybe 12 offsets and so on, right? So now what is happening is within this offset, we are going to keep some messages, right? Because partitions are the message, but those messages are also going basically with respect to this, and these are immutable. Again, once it's there, you cannot change it. And you could have like as many as you wish. It will keep on increasing. Like if a new message comes up and if it goes to, let's say, partition 0, it will go to a new offset. It will create a new offset and will take up all this data accordingly. So that logical messages which I have just created here, right? So think of it like maybe at 0 offset, this data is setting. India won Asia Cup 2018, right? So now the 0th index is like the older data, which denotes basically this data set I got it earlier. And let's say if I'm similarly, this would have gone to, let's say, till 12, let's say, just taking example. Then the 12th one is the most recent data which partition 0 have got it. So this is basically the way we define these offsets. Again, it was very important for you to understand that how internally Kafka kind of keeps the data. That's the reason I'm just drawing all these diagrams to explain you this concept. Okay. Now, so this is going to be important because we can even retrieve the data using all this offset partitions and all that, which you will see in the code as well. But again, the understanding is important. And all the new writing, for example, if I talk about partition 0, so now the new writing will happen only here on the 13th offset, and we will write something here. So all the write will happen from here. And it is also possible, maybe there's a reader, maybe consumer who wants to read this. So maybe he can say that, hey, I'm only interested in reading this. Maybe consumer B, there's a consumer B who is reading from here. Maybe there's a consumer A who is reading from this offset. Possible. So that way, we can also have the parallel reading very well arranged in this case. Okay. So all that parallel reading, you can very easily have it and kind of go about all these offsets as well. First of all, everyone now clear how the data is kept, what is partitions, what is offset. In fact, if I come back to this diagram, now are you able to relate this diagram completely? Any question on this part?
Shivang, regarding offset,
Yes.
The tweets, the messages will go to a particular offset, like multiple messages can go, only single message will go.
Single message.
So every message will have a unique offset, right?
Yeah.
Okay.
Again, there is a configuration setting, but just by telling you this part because there is a tweak which you can do it, but that's a default nature which I'm talking about.
Okay, sure. And one more question. So you said Zookeeper will be like handling all the brokers, right? So can we replace that by using Yarn or Mesos? Like, is it like default Zookeeper only?
No, we will always be using Zookeeper with it. Yes, there are hacks for it, to be frank. Not with Yarn properly, but there are other softwares which I have used it specifically. But Zookeeper is the best one to take care of it, given it already have all the logics being defined. Even you will be surprised to know that I have even used the Cassandra sort of logic applied to it. And basically we have used the automated thing for this. This has worked really well, but again, it failed to scale. So we stopped using that.
So the high availability will be handled by using partitions, right?
High availability is not just by partition. We also have something called as replication here. So that's the next thing I was about to talk about. So I think I've already talked, right? So this Twitter topic could be even replicated around into different machines. So that will also ensure your high availability.
Okay, sure. Got it.
Any other question, guys? I hope all of you are clear with this. This is important, guys. Again and again saying that because people just know a lot of times, okay, this is all the commands which we have to run, but you should really understand what is happening within all these components as well. Okay, now what is the next thing I'm going to do is I'm going to come to now some coding component, okay, which we will do in the first half, and there will be some components which I will be talking from it. Now, when I say that I will be covering now some components of this, so what basically I will be doing here is I will be going to explain you now how to work with the Docker. First of all, have everyone downloaded Docker now? Is there anyone who do not have it? Please let me know right away. Everyone knows it? Perfect. Now, first thing first, what is a Docker? Okay. So when I say Docker and why I'm even using it, I think I already told you that the reason we are going to use Docker because a lot of companies can end up giving you this. Secondly, I wanted to show at least one topic using Docker. And at the same time, since in this Docker, everything is already set up, so we need not waste time to kind of setting up and doing all those stuff as well. So let me very quickly walk you through how Docker works. What's the main idea behind it? So let's say you have your system. Earlier, what used to happen, for example, if I talk about your virtual machine, which you are using the Cloudera VM. Now, what happens there is like you have, when you did that, you have to use some set of RAMs. When it's open, right? Even if you're doing something in that, or it doesn't matter, it's open. Now, what container basically do or what Docker do is, it basically says that, okay, I need, let's say 2 GB RAM and so on for running my application. And when I need it, only at that time I will occupy your RAM. Otherwise, I'm not going to use it. I'm just going to release it and you can again reuse that. So that's one advantage what you get. So as soon as you will close the Docker, all the things will become available for you. That's one thing. It's very lightweight. Why it's lightweight? I will come to that. Secondly, what happens with this is, let's say you have a Linux operating system here. Now, what happens? Let's say you need a Docker. On this Docker, maybe you are using some other operating system, which could be a Linux, but a different flavor of it. So now in this case, what happens is when you are bringing that, maybe you will not be loading the whole operating system, because if you know your operating system eats a lot of your space, your RAM and so on. So what Docker specifically do is it says that, okay, since I'm using, let's say the base operating system is Linux only, so that I will be reusing some files which is already there sitting in your laptop. I will not kind of go and install them and set up everything. Maybe the last remaining some files which are a little different, maybe the 5-10%, 10% of the files which are different, I will only bring them. I'm not interested in everything here. I'm only interested in few of them. So that is the second thing which we can also do it here. Now, one more quick thing which I want to show you up here. Let me close this. Okay. Now let me make this bigger. Now, so let's say if I want to see all the images what I have, so I can say Docker images. So what happens is you have already, somebody have done a lot of work for you, and that work is already available now on your system, right? So that's when I say on your system, you can bring it directly from that. So you need not recreate all those things. So you can see here also, like I have some images being available in my system, because you can see the last one specifically, which I will be using it now. Now, if I want to, let's say, bring Ubuntu right now, right? I want to bring Ubuntu systems. What I can do simply is I can say, hey, Docker run IT. You can think of it like when I say, sorry, I want to basically go inside this also. So I will be going inside this also. And I'm going to say that, hey, Ubuntu is what I need, /bin/bash. Basically, this command is required because I want to go inside it, and maybe I want to start my bash commands and so on. So here, what it will do is, look at this. So first you saw this, it says that unable to find the image Ubuntu basically latest locally. What do you mean by that? It means that this file is not available on the local system. So it is going to go somewhere called as Docker Hub. And from Docker Hub, it will go and get the latest version for your Ubuntu, and you can start using it. Okay. So you can see that it have downloaded. So let's say if you do this again, now next time this is available in your local system, so you will not get this. So it will take up from there itself. So that's another thing for it. Now, other than that, if you want, so even if you want to, let's say, see now the Docker images, we can see it here. If I want to say, Okay, I think I'm doing one mistake. I was already inside my Docker and I was doing all the steps. Yeah. Okay. Anyway, so after that, if I want to see anyway, if I say, let's say Docker images and so on, Docker images. So you can see now there is a Ubuntu image also showing up for you, right? So that's how you can see all this. And then after that, if you want to work inside that, you want to go inside it, you can have some commands like Docker start, give your container name, right? So it will go and work on that. So all these things are related to Docker. I just gave a very quick overview. Anyway, some Docker commands I will show you in the class itself. So while doing the Kafka, let's keep the intent around Kafka only right now. But yes, these are the basic commands which basically you can go about it. Okay. Anyone who do not know at all Docker on this part, if you can let me know. Everyone knows it? Perfect. Then why we were doing this?
No, Shivank,
Oh,
I didn't know.
oh Karthik, you don't know. Fine.
Even
Yeah.
I don't know, like basic I know, but not used.
Okay, if you know basic, that's more than enough because I'm not going to use any strong command as such, which is going to relate it to Docker. Instead, what I'm going to do here is I'm going to just use very, very basic commands, okay, which I will keep on explaining you what this command do. And once we are inside a Docker, everything will be Kafka based. It just to create a Docker, which have Kafka compose, Kafka available for me. And after that, it's all Kafka commands. Now, so any questions till this point from anyone? Okay. So since all of you are clear, let's do some coding. 1 second. I will be giving you some code files in your basically in your Google Drive. Okay. Now in that Google Drive, basically you can go ahead and you will be able to get you should be able to execute everything whatever you need. Okay, that's number one. Now don't execute it before I show you because there will be some steps here and there. If you miss out, then you have to remove it and it's going to be a tricky task. But first, let me explain the first component, what I'm going to do with this, and then maybe you can take it up from there and start working on it. So the files will look something like this for you. Okay. So you will find inside the code directory, once I will upload, you will find all these things. Like for example, there will be a docker compose.yml file. I will explain you what is this. Inside this, I will be doing something. Then I will have Kafka Connect for syncing part, where I will be using something called as Elasticsearch, Postgres, SQL, and so on. Then I have also the source part where we will be talking about how to load the data basically from the normal systems, file things, you can bring it from Twitter and so on. And a lot of other activities, which I will show you once I will move to the Kafka Connect. Anyway, before that, I will also show you how to work basically on the normal Kafka also. But in this file itself, I have put down everything for you. For example, let's say if I open this, look at this part. So here, the first thing first, I will be using something called as Kafka cluster. And I want to execute this Docker, right? First of all, let's understand what is this Docker compose is going to do for me. So let's say a client came and he said, hey, I would like to basically run some Kafka component and they have some code for it. Now, one idea is that you start going and start setting up full things for them. Maybe you're just creating a POC, which will not give you any money also. So in those cases also, we quickly go ahead and create the Dockers so that we have everything already available with us and we want to use it. Second reason I already told you was, let's say, I have some remote employees. For example, I am generally a remote employee for a lot of companies, which you will also be in going future. So when you will be working for the clients, now you will be asking them, hey, give me your setup environment where I can go and start working. Maybe you have set up all the environmental variables and all that. I would like to use them. So what those people can do is they can create a Docker image. In that Docker image, they can put their full setup, what is required, and they can give you that environment. Then they will upload it on Docker Hub. You have to just call it by using Docker pull, the way I just showed you for Ubuntu also. And once you are bringing that up, what will happen is now that whole setup is available and you can start working further on top of it. After going inside the Docker, you again finish some work, again upload the Docker on Docker Hub and start working. So all those things, you can do it quite easily with the help of Docker. Now here what I'm going to do is, let me first show you what is this Docker compose file is, because this is the major file for us. Now in this file, if you look at, I have all these things with me. For example, you can see I have, I'm just using something called as version 2. And here what I'm doing is I'm creating 3 things. For now, forget about Elasticsearch and Postgres. Let's only target on the Kafka cluster. If you recall, when I was running this command also, I said Kafka cluster, right? Which means this Docker compose will help me only to execute this part. Now, what is this part? I will explain you. But it will only execute this part. It will not go to the other part. That's the reason I said that ignore the rest of it. Now, what is the first thing I'm going to do? In my Docker Hub, there are people have already uploaded their images, which are like available for general public. They have already put down a lot of configuration. Even Hadoop images there. You can go and set up your Hadoop also by using Docker. Again, Docker also takes up your RAM. Keep that in mind. Just like the virtual machine was eating up your RAM, even Docker will also eat up your this part. So you can also, but try to do some coding on the, maybe create a Spark Docker and try to work on that so that you don't need to install the Apache Spark. Right? That's all you can try. So now for Kafka specifically, Hadoop, which is basically a component, is you can think of somebody as a company or maybe a person who have provided you an image called as fast data dev, and this is like a version for it. Now what it will happen is, once you will bring this image to your system, this image will, when you start it, it's called a container. So that container will have Kafka and everything already set up for you. So you don't need to bother about anything. It's a very, very famous image actually available there. Plus, Hadoop also provides you sort of UI, which is very good. I will show you that UI also. It makes your life a lot simpler as well. So that is the first thing. So we will be loading this image. Second is, I am going to use what host. This is the IP of my local address, right? So I'm just telling that. Run test, I am disabling it to 0. This is mainly if you have, let's say, some test, you want to run it quickly and check it whether all the changes are fine, then we use it. So ignore that for now. I'm just disabling it for now. What are these ports? These ports basically means that on what port what is ready. So let's say if I was Zookeeper will run on a port, right? When I said Hadoop have its UI, so it also will have its port, right? Similarly, even there will be some REST commands also I will show you that also have their own port. Even JMX have its port. We will not be using it, but it will be used internally. Then Kafka broker, that will also have its own port. So all these components will have their own port, which we will be using up here, right? So now what is this, basically this, why I'm using this hash, this colon symbols here? Because you're running this Docker from your local machine, right? So in your local machine, you are going inside some other machine. That's what you're doing, right? Basically from a local machine, you're going inside some other machine. So now you need to tell that, okay, from this machine, if I'm basically doing something, what is the port here? What is the port there, right? So you're sort of mapping them out. That is the reason we are doing it. Again, I'm just telling you at a very high level. There are some more things within it, but this is just for your quick understanding. Think about them for now as a port for Zookeeper. And I'm just doing some expose or mapping basically from my local system to that Docker machine for now, right? Just understand this much for now. So this is all the things which I need for now. Now, what is the first step I need to do then? In my case, it will run very fast because I already have this image. But what I will do here, I will just go ahead and execute this command. Since it's available locally, it will be quickly available for me. You can see here. I could have gone and delete this image also if I wish to, but for now let me just use it. So I'm going to say Docker compose up this, but it will fail. Why? I need to go in that particular directory to work in that. So it will need basically that this compose.yml file, the file which I just showed you here, it will need that particular file. Otherwise, it will not be able to do anything. It will just throw me an error around right now. So what I have to do, let me go inside this. Let me open a new terminal. Let me go quickly to this directory. Here you go. Okay. If I do an ls here, you can see I have this docker compose.yml file, right? It's available for me here, which I can use it quite well. Now, what I want to do here is, I don't need this now. Let me close this. Okay, so I need only this much. So what I will do here, I will now say docker -compose up Kafka cluster. Now, one important thing, you have to ensure, because I'm having some ports here, right, that all these ports are free. Maybe you are running already some Kafka application right now, and that is installed in your local system. Maybe that is using 9092 port or something already. And then in that case, if you will try to hit this, it will start giving an error. Okay. If that is your condition, my suggestion in that case is either you can kill those ports and basically then do this setup. Otherwise, what you can also do is just restart your laptop. Okay, all those ports will get free. You need not bother about killing them and all. Quickly restart, all your ports will get free, and execute this. In case if you get any error, do this. In case you do not get, then it's fine. Means anyway, people who are already running Kafka or something on a local machine, you will be well aware of that, what you have it or not. So let me execute it. It will be quick for me. Like I said, since it's already sort of set up for me. So you can see just seeing that I'm starting the code Kafka cluster 1, and it will do all the operations for me. Let it complete. Now, so you can see that it started working. It's all up for me and it's in great shape. Now, what is the next step I will do here is, let me come here and show you how I can open up the port. In fact, that is also I've written down here. So what I will be doing now as a next step, as soon as I came in, I have to now go inside a port, which is going to be 127.0. Let me show you here. You can see it here. Okay, I just opened it. 127.0.0.13030. You can see it's all coming up. Even this takes some time. Sometimes it gets stuck also. So if that happens, I have to restart it. But it has to start. Connectors is the main important thing which I need actually here. But it will take some time to start. Now what I'm going to do, let me give you these files for now, so that at least you do this step first. Okay. Then we will go inside this container and start working. But let's you also complete the first step. So for this, let me go to your Google Drive. Okay, go to your folder. It is taking some time meanwhile to upload, but it should be uploaded in a minute. Go to your folder. Inside that, I have created a Kafka folder. It got uploaded by now. Let me send you this on the chat box also. Okay, all of you go to this folder quickly. You will see a code folder inside Kafka. I created a Kafka folder. So inside that, you will find a code folder. Go and quickly download that, all of you. Once you download that, open this first file. So I already told you, right? Kafka connect tutorial sources.sh. This is what you need to open, which will be this. It have the command which I've already put down here. Say docker hyphen compose up Kafka cluster. It will take some time. I've already written also. Wait 2 minutes for the Kafka cluster to be started. All of you do this so that in 2 minutes your cluster is ready. Just ignore what I am doing. You have to just complete your step. I just got some duplicate things. So I'm removing that to avoid any conflict.
Shivank, I'm not able to run that source.sh file. Hello.
Oh, sorry, we have stuck on mute. Yeah, which file you were not able to run?
Kafka source.sh.
Kafka, you are not supposed to run Kafka source.sh, right? I just said open that file, go to the directory where you're keeping the code, where you have this YML file, and execute this first command, docker compose up Kafka cluster. That's it.
Okay.
Guys, let me know once you're done, because I have to explain you the next step after that. We will be in the next step, we will be going inside this actually. Done, everyone?
I'm getting this error, Shivank. Docker error,
What error?
Docker. I just pasted in chat.
It is clearly saying that the file which is looking for, you have not given it. So what is happening is that you are running it from either a wrong place. Please ensure the way I have done it, do it in the same way. So what you're supposed to do here is, in whichever directory you have file, from there only you have to execute this. What I mean by that, when you're running these commands, you should be inside the folder code which you have just downloaded, which have this docker compose.yml, because it's saying that it cannot find the file specified.
No, I'm running in the same folder only.
Then give the permissions in case if your operating system have permission issue. Use it the chmod command,
Okay.
because it's a simple docker thing. So there's nothing we have started yet on Kafka. Once you're done, guys, let me know. Anyone who have reached to the stage, at least running or something?
I was able to get the cluster cluster running and see it on the
UI. Okay. We have hit this 1 2 this with 3030.
yes, yes.
Okay. Yeah, just wait for it then. Done? Okay, let me show you one more thing because we have a break coming up. At least we can finish some commands meanwhile. And what you guys can do it maybe during your break time. If you're not able to yet hit it, you guys can continue to kind of fix this thing at that time, and you will also have the time to perform some more activities around this, right? Once you're done with this, ensure that you open a new terminal and keep it open because your otherwise your container will stop. So you have to ensure that this is running for you. Okay. Otherwise, you will not be able to do any activity. I will keep on explaining you from this file so that it's more easier for you to do that. Here, what you have to do that is I want to go inside this particular Docker. Now, one important thing here. When I want to go inside this Docker, I am also telling here that whatever data I have in my current directory, what I mean by that, if you look at this, if I do an ls here, let's say if I do an ls here, I have all these files, right? So whatever data I have inside this directory, go inside my container, create this folder called as inside root directory, create a tutorial directory, and copy all this data, which is here inside your container now. Okay. So what I'm doing is I'm bringing all the data from a local system to container by using this command. And what this Docker run will do, it will go and basically let me enter inside my Docker now. So I am, and make sure if you're using the Windows, then do this command. I've also written down for you. So this will work for you in that manner. Let me come here and execute this. Now what it will do, it will take me inside the container, keeping this tutorial directory copied. So right now, can you see it just all changed? It's at root at the rate fast dev something, right? It is not currently into my machine, but it's inside my Docker. So I am just telling it here that run this and go inside it, but make sure that whatever I have in the current directory, copy it. Let me show you also. If I do an ls, actually, if you look at it, I'm inside my root directory and look at this tutorial. If I go inside tutorial, notice all the file have came up here. Whatever file were there in my local system, it have copied it. And then I just said that, hey, go ahead and execute this basically image what I have and execute it like a bash script. Because when I insert, basically it's a bash what I have in the Linux right now. So all the files went in this manner and you can see this. That's the step number one, what we just understood. Okay. Everyone clear how to enter inside? You can actually try this maybe during a break or maybe after the break also. I will give you some time. Don't worry about it. But ensure that you understand this well, and all the commands I'm showing you from your this part, that's it for the same reason. Now what I want to do is I would like to see maybe what all topics I have in Kafka. We just saw that what is topics. Now we would like to understand what all topics I already have inside my Kafka. That is what I want to see here. Now, for doing this part, what I can do, I can say Kafka topics, and I would say hyphen list. Now, I want to see the topics, but I need the help of Zookeeper. Otherwise, we will not be able to get this to see this topic. So I will say Zookeeper, and I will give my port here. So my Zookeeper is running at what port? It runs on 2181. Okay, so I will say 127.0.1.2181. Okay, if I do this, now you will be able to see what all topics it already have. So you can see all these topics showing up. And basically you can see demo 1 and so on. I will be this, actually I just ran it before your class itself. That's the reason you're able to see this, but we will be creating all this. Okay. So this is basically going to be the way you will be seeing your topics. Everyone clear on the first part? Perfect. Now, yeah.
Actually, Shivank, I have a doubt with the tutorial part. We don't have any folder called tutorial. So when you tell pwd/tutorial, from where will it pick?
No, so again, don't get confused with this part. Let me show you what it have done. It have not picked up from your tutorial, but instead what it have done is, let me open it here. Yeah. So if you look at this, this is my directory, which is on my local machine. Okay. Now inside this directory, I have all these files, right? This part is clear. So now what it have done is, it have basically created inside my container a folder called as tutorial, number 1. So as you can see, when I'm inside my container, that's the reason I was able to see this tutorial folder. Now what I'm telling it, whatever is sitting into my current system, basically in my local machine, whatever files are there, go and
Shivank,
put inside that.
Maximize the screen.
Sure. Okay. So go and put inside that. So what I mean to say is, so what have happened is, I have my local system. So let's say this is my local system. Okay, this is my local system. And I have my container. Container is that basically the one which we have just created using Hadoop thing. Now here, what I have is, I have a code folder. Inside my code folder, I have a lot of files, right? So I'm running it from my local system. Now what I'm telling it, that go in my container, create a folder called as target, first of all. So create a folder called as target. You can name it anything else also. You can create it by Surbi also. And what it's saying is, whatever is present in this folder, inside code folder, which is from my present working directory, whatever is present in this folder, go and copy inside this target folder, which is sitting into my container. Clear, Surbi? What it have done? So right now, that's the reason when you came up here. So whatever your files were present inside your local file system, which is your code folder, it have basically copied it inside the tutorial folder, which is created newly, and inside that, which is present inside your container. And inside this tutorial, you can see all the files getting copied from your code folder. Now clear on this part? Who asked this question? I think should
Got
be
it,
for you, right?
Shivank. No, Aditi.
Okay. Everyone clear on this part? In fact, there should not be any confusion on this. Okay. Now, the second thing what we discussed was how to basically look at my Kafka topics and be able to see all the things running there. Right? So what I've done is, basically, I would like to see what all topics we have basically available inside my basically Kafka. That's the first thing which we want to check here. Now, second thing is how to create all these topics. And once I create this topic, how to insert the data inside this topic, and which can be viewed by your consumer aspect. That is the next thing we will see. So let me first show you how to create a topic first. Now, in order to create a topic, what all things I will need? So first of all, I will say, I want to create a topic. So there is a command for it called as Kafka topics. Okay. Now inside this Kafka, what I want to do, I don't want to list, but I want to create it. So I'm going to say create. Now it is similar to when you go in your database, you say create table name, right? Same thing here you have to do where you want to send the data. Now you have to give some topic name. So you are saying, let's say topic, and let's say I want to create it by name Shiva. Okay, I want to create it by this. Now, by creating this topic itself, I will be telling that how many partitions I have. So I will say hyphen partition, and I'm going to say, let's say I want 3 partitions because I will be using something in that. So now I'm creating 3 partitions. Now, how many copies I want to create for this topic, Shiva? So let's say I'm going to say replication factor. Replication factor is going to be equal to 1. That's 1. Now I need to take the help of my zookeeper. So I will say hyphen hyphen zookeeper, and I will be passing on all this. I will say 127.0.0.1. This is going to be 2181. Okay, same port number which I used it for when I was listing it as well. So now when I execute this, have I done some typo here? Should work. Okay, yeah, I did one mistake because it's not partition, it's called partitions. Sorry about that. It should be partitions. Now it will work. So now you can see it said that I created a topic called as Shiva. Now what is the next step I will do? I want to list down and see whether the Shivang part topic will show up for me or not. So you can see here, Shivang is showing up for me, right? So this is all, so you can see here, right? The last one. This is a Shivang, which is available for you. So this is the way you will be viewing all of your topics and so on. Now, one more thing which I want to also show you up here is, if you look at this, let me close all this. You can see this connector loading took a good time. This will also happen for you. You have to be patient. Maybe leave it for 15-20 minutes. Make sure that you do it now itself so that it takes time. Now, right now it's showing me 2 connectors. I will be creating much more. Let me open it in the new terminal. And you can see here, I have some things available as well, right? Now, what I want to show you here is, this is for your connector, which we will see in the Kafka Connect portion. Now, I also want to show you, you can see the topics also here, right? Let me do a right click and go inside my topics also. Now, when I'm here, you can see that I have created just now a topic, Shiva, right? And can you see here it's saying 3 partitions, 1 replication? Click on it. It will show you no message because I have not yet inserted any data. It's saying that it's data. I have not put any inside it. Partitions are 3, but no data right now inside it, right? So that is what you can also see it from your UI as well. Okay. So once this will open up, this will, like I said, it do take some time. So you have to be a little patient with this. But this is your Kafka Connect, which we will be using it for creating a lot of things as well in today's session. And secondly, this UI, we will keep on seeing it quite easily to see all our topics as well. Any question on this part from anyone? Now, one thing, whatever thing I have hit down here, you could have also done it on without container also. Container is what? I just created a machine where I have my Kafka installed, nothing more than that. Where my Zookeeper is already running, where my Kafka is already running. So maybe when you will get already, let's say, maybe your administrator has set up everything for you, which you don't need to generally set up. So in that case, you have to just think about executing these commands only. You are not going to be bothered about anything else. Okay, that how to list down a topic, how to create a topic, and now after that we will see how to insert the data inside this topic, and after inserting, how to consume this data by using a consumer. So when I will say I want to insert the data with a topic, it means that I want to use a producer to send some data towards my topic. Then after that, I will be using a consumer to take that data which is present inside my topic and read it. Now there will be 2-3 cases within that, which we will also see. But before that, I want to also basically tell you one more thing. It is not mandatory that you create your topic like that. Sometimes when you are giving it to producer and let's say you gave some name of the topic which is non-existent, it will create automatically also. Okay, but I don't recommend that to be used as well. It's completely your call how you want to do it. One more thing is, once you have created your topic, you can even update it as well. You can even change some properties of your topics as well. What I mean by that, you can basically what can happen is there's an alter command. Maybe a lot of times it happens that initially you thought that 3 partitions are good enough, but maybe you later you felt that I need to change the number of partitions. You can do an alter. I will show you that as well. But before that, any questions on this? Any questions on this? Okay, perfect. Now, how many of you have already set up this container? So in second half, let me tell you what we will be walking through. Mostly, I will be only creating the containers. I will be showing you how it works. Only at few places, I will be asking you to execute maybe the initial level commands so that you get some idea. But Kafka Connect being an advanced topic, I will be mostly showing you up. Maybe for one of the case, you can try it, which is a smaller case to start with. Since I've already given a code, you have to just copy paste. But other than that, mostly I will be doing it up just to show you how quickly all these things works. And you have to go back and practice it. Okay, that's something you have to sort of look at, because the reason is we have to make sure that we kind of finish all the activities which was planned for it. So that is something which you have to ensure that you go back and practice on it. Any questions or any trouble right now with this? Okay. So what I'm doing is I'm giving a break right now. So we will be connecting at 1:55. Okay. Instead of 2, we will be connecting at 1:55 because I don't want to break the continuity of it. But it's a 1 hour break. So make sure that you're back 5 minutes before the class, means our usual time. And if it might be possible that we can go beyond 4 p.m. today. Just telling you beforehand. So I hope we have already discussed this. Everyone is okay with that. We will see to this how much time it will take, but we will. I have to ensure that whatever we have planned, we will finish it. Okay. So it may be possible that we may go till 4:30 or maybe 4:45. We will see to that. It depends on the hands-on activities as well. Okay. So be back by 1:55. Make sure on this part. Okay. So you are also having the time now to, if during the break time, if you want, you can set up your systems, get the things done. I think Aditi, you have completed it, right?
Yes,
Aditi?
Shivank.
Yeah. So maybe guys, whoever need help, you can take help of Aditi also during the break time. So maybe Aditi, you might receive some phone calls now. Uh, so you can take help to get your things done because you all are using the same operating system. So you guys can check accordingly and get your things fixed. Okay, fine. So let's connect at 1:55. Thank you. Okay, is everyone back now? I can see only 10 people back. Girish, can you quickly check if we have any internal communicator?
Yeah.
Okay, meanwhile, all of you who are sitting here, is there anyone who is facing still issue with the Docker? Okay, so I'm assuming that all of you have set up now the Docker to work on Kafka. Perfect. Still, there are just 15 people.
So Shivang, let's give it a minute for joining. So Shivang, let's not wait. Let's start our last session.
Okay. Yeah, I hope they all joined. Reason being, if they missed out, it'll be a trouble. But yeah, let's start anyway. So first thing we just understood right now is how to create a topic. We just created a topic called as Shivang by now. Now, what is the next step we are going to do is we are going to now go ahead and send some data to this particular topic. Now, how we will do that? So for doing this, we have another command, which is going to be Kafka hyphen console hyphen producer, and here we can define basically what is my broker list, because I will be sending this data, right? So it is going to a broker now, right? So what is that broker? So that broker is by default going to set at 9092 port. That is what being configured by default by Kafka, but it can be changed. If your admin has changed, then you need to get the details from him. So for me also, it's going to be 9092 because I'm using the same portion for it. Now I'm going to say here that I want a topic. I want this topic, and basically which topic I want to write here. The topic is going to be Shiva. Okay, that's the important step what I've done. Now I can write something here. So I can say, hello, Shivang, big data. I'm just writing something. Okay. Now, as a next step, what I'm also going to do, let me open my another terminal, because I would like to also open for a consumer. Because right now what I did, I wrote using this producer into the topic Shivang. So right now I'm just going and writing something on top of it with the help of this Kafka console producer. But I definitely also have to read this from somewhere, right? So in order to read this from somewhere, I need to come in and basically go inside this again. So for that, I can go inside it. So once I'm connected, now what I have to do here is I need to hit my consumer for the same topic, Shivan, where my producer have written till now. So I'm going to say Kafka hyphen console hyphen consumer. I want to read the topic called as Shivang. Right? That's the topic name which I want to read. Now, one thing is I want to read it from the beginning. Means whatever I have written it in producer already. For example, if you notice right now, I have already written hello Shivang big data. Right? So I want to read it even that hello part as well. So for that, I have to tell it that start it from beginning. Okay, start it from that. And again, I need to tell that, okay, go ahead. Oh, in fact, there's a spelling mistake. Yeah. Then after that, I have to also tell it that what is my Bootstrap server, basically where my broker is being set up. So I will say Bootstrap hyphen server. And I need to give the port again, which is going to be 9092 port by default. One, I'm going to say 127.0.0.19092, and I want to read this now. Let's see what's going to happen. Okay, I think I did some mistake here. Let me quickly see. Okay, fine. I did some typo then. So let me remove this. I don't want this part. Let me come back here and let me just quickly check if I have given the same name, right? Shivang. Okay, I'm writing in the same one. And hit this. Let's see what's going to happen now. So you can see here, I got big data, Shivang, hello. Definitely the ordering could be different, but I got this data. Let's add few more. Hello, something, 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 something more, field, and so on, right? Come back here. See, all the data is immediately read. Think about it now like your WhatsApp systems. If you are sending a message, it is sort of going to be received by a consumer. So when you are sending from a mobile, you become a producer. Now, maybe it is going on a topic. Maybe the topic could be anything. Let's say if Arun is sending a message to Abhishek, so maybe the topic name could be when Arun Abhishek, right? Whatever they decide to. So let's say when Arun is sending message, so he became a producer and Abhishek going to become a consumer. So first Arun have to write a message and send it. That's what the job was for the producer part. That's what we did here. So here I basically write it to producer. And then basically you can see here that I said that, okay, write it on this particular broker. And this is my topic name, right? Once it have written, then after that, once the communication is happened, right? So let's say whatever Arun is typing, Abhishek will keep on getting it, right? So that's what basically this is sort of going to look like. Now, if I come back here and go to my topic in this particular place, let me go to Shiva. Let's refresh it. Let's see this data, how this will look like. Look at this, right? I am getting some data here. Very interestingly, it is also telling me that this big data, it also automatically internally create a key for you, which is just to identify, just like your map reduce, right? Now, here you can see this big data went to partition 2. This one went to partition 2. Then I wrote this one, this went to partition 2. Shivan went to partition 0. All these values also went to partition 0. You can see even these values went to partition 1. Recall when I created the partition, I created 3 partitions. So that's the reason I'm seeing all these values going on in different partitions. Even if I want to check all this from my command line also, for example, if I come down here, this is my consumer. Let me stop it. And now what I want to do is I want to tell it specifically that go and read it maybe from partition 0. I can define it as well. So as soon as I will hit this, now notice what's going to happen. It will go and read only the data which is sitting in partition 0. Okay, so that is also feasible when basically I can hit my producer and consumer. Any question on this part? How I have written this? First of all, we saw how to list a partition, how to create it. Sorry, not partition, topic. How to list all the topics. We can create a new topic. We can define what's the replication, what's going to be your number of partitions. Then after that, we saw that how we can send the data from using a producer to my topic, what we want to write. That's the first step. Then after that, we saw how we can read the same data using the consumer, and basically whatever we are writing, we are able to see. Now, I want to also show you one more thing here. So in case if I will not give, let's say, this from beginning, then let's see what's going to happen. So I'm giving everything same. Let's remove this. In fact, let me also remove this partition 0. Rest of the things you can see is same. There's no difference there. Now, notice there is no data being read up from hello, Shivang, big data, and so on. There's no data read like that. But if I will write something new, like if I say hi, now notice this data will come up here. It's taking some time, but it will come up here. So what will happen in this case is the new data will only show up to you, but the older data will not show up to you at all. Okay. First of all, everyone clear with this? Whatever we have discussed? Any question from anyone? Okay. Can you all now quickly go and create your producer consumer? Create quickly a topic also, so that you should be able to basically execute all this. I'm just sending you this commands on the chat box for now. Not chat box. Let me send it to you on your Google Drive itself. One second. Because I don't want you to type all this. I just want you to quickly make sure that you are able to do this operations. Okay. You can go inside your Kafka folder. You can check it out now. It's available. I can send you the direct link also for the same. I have sent you the direct link also. I just named it as Kafka itself so that you can quickly do this. Okay. So the producer, the consumer, both I have given to you now. All of you quickly do that. Go to this link. You can copy paste, feel free to do that. Maybe create 4 partitions instead of 3. Rename it, do it with your own name. See if you are able to do all that. After you have created it, make sure that you're able to see the partitions also. And also one more thing, whenever you're opening it from here, try to see if you open it to the new terminal. Otherwise, what happens is when you want to get back, it will not be able to. And then what will happen? Then you have to again wait for this connector to come up, which takes almost sometime 20 minutes to 30 minutes. So that's the reason. Do a right click and then go to the new page, but don't go from here itself. Okay, that's what I have also done it just to ensure that everything is fine. Anyway, this is not required. Yeah, so we can see it here that what I have done. In fact, I can do it here as well. This is one of the major problems with this. Sometimes this connector starts failing. It was working earlier, right? Okay. Even the same problem started happening with me also. I need to refresh it now. There is no other way. I have to wait for it to come up. Anyway, meanwhile, we have some other things to do. I think during the break time, it just broke out the connection. In fact, close this. Sometimes this refreshing also don't work well. Once you're done, just type done for me so that I'm aware of it. If anyone is not able to do this exercise, please let me know. Like why you're not able to do it. Is there any problem you're facing? So that I can help you with that. But please make sure you're working on it.
Shivank, actually, I mean, I ran that Docker compose a cluster command, and it was creating this cluster, but it is saying that RAM available is less than what is recommended, and now it is taking too much time to finish this cluster making only.
Okay. What's the RAM you have?
No, I have RAM 8 GB, but it is showing like operating system RAM available is 4700 MB. Lowest recommendation is 5000 MB. So something like that.
Can you
I
do
mean,
one thing? Start your system. Maybe some RAM is taken because even I have 8 GB RAM only in my laptop. And
this
yeah, if you can see this part that you're in, just try to restart maybe Karthik. Anyway, people are doing this exercise because what is
okay,
happening if it needs that RAM and you are running some process or maybe some invisible process which is eating up your RAM, at least that will get free.
okay, fine. I'll restart then.
Okay, Gaush, Aditi, Manju are done. Perfect. Everybody else quickly do this. Last 2-3 minutes. How about you, Arun? You able to complete it? Arun?
Were you talking to me, Shiva?
Yeah, yeah. Have you completed it?
Uh, I was running another application on my computer and it crashed, so I'm just trying to.
For you also. Okay.
Mm.
Last 1 minute. For people who are not able to kind of do it in the speed because of the Docker issue, RAM issue, you can even try it later. But main thing is you should understand all the concepts what we are going through. That's very important. Yes, with people who have lower RAM, this problem comes. Even right now, my own system is hanging a bit. But still, I have to ensure that I teach you with the Docker. Because Kafka do takes eat up a lot of RAM. Okay. So guys, let's go ahead and see few more commands now. So we just noticed how to get all this data from all these partitions and so on. If I want to again list all this, like if I want to list again this Kafka topics, what all we have, we can see now. So let's get it open. So this Kafka topic hyphen list zookeeper should show me up now this topics. Fine. Maybe I want to delete this topic called as D. Okay. I want to delete this up. So the way I can do that is I can do with the help of the delete command. Okay. So I can simply hit mistake. I gave another topic name, but that's also fine. You can see there's one more topic name called as demo1 standalone. Let's say I want to delete this. So I will just say Kafka topic, zookeeper, give the port for it, and then say hyphen f and delete and give the topic name. It will just go ahead and delete it. Since my system is responding slow, that's the reason all these outputs are a little slow. And I know why this is happening. It's eating some portion of my RAM. I just checked it. So maybe once I will give you the next portion, I will make somebody among you as the host, and I will just restart my laptop quickly. Okay, so you can see now it's showing that it is showing mark for deletion. And if I want to quickly confirm, so earlier I was seeing this demo1 standalone, but now I will not be having this demo1, right? In fact, I would also like to remove the demo2 as well, because I will create a complete new one. And I will also remove, okay, it does not exist. Okay, I gave a typo here. It should remove demo2, and I will also remove demo3 as well. What I'm doing.
It is not present only.
No, this one I want. Okay, this is this. Correct. Sorry. Let me remove this, and I also want to remove this one.
Can't we execute it in one single command, like giving space?
Yes, with comma you can do that. That should be fine. Now, so I have deleted all this because actually I will be recreating them by doing some Kafka Connect demos. But for now, basically this is how we can delete all this. Similar way, if I want to do some more things as well, yeah, this will have no impact. Correct, Pancha? Yeah, one more thing if I want to do is, maybe I would like to see the details related to my basically some topic, let's say Shivak, which I created, right? So what I can do, again, I will use the same thing, Kafka hyphen topics, zookeeper, I will provide this detail, but instead of this delete and all, I will say now describe, and I will be defining the topic which I want to investigate. So I can say topic, and maybe I want to do the look at Shivang topic. So you can see here, it started telling me that now I have these topics, and basically I have 3 partitions inside that. It's also telling me that how it's handling the replication factor. Anyway, it's only one. And basically these are the details for it. Now, one more thing which I want to do is maybe I would like to change it. So let's say I want to make it now alter, and I want to maybe change this time for the topic. So I will say topic, and I want to do it for topic Shivang. But what change I want to do? I want to make now the partitions as 2. Partitions as 2. Okay. So instead of 3, now it should make it 2. Now one question for you. Okay. Let it complete, then I will ask you. Okay. Look at this error first of all. Yeah. Good thing it came up. Number of partitions for a topic can only be increased. So as soon as I try to make it 2, it started complaining. You cannot decrease it, because what will happen to your data then, right? Now let me make it 4. Okay, let's see what's going to happen now. Now this new partition came up, and if I want to go and describe it, let's see what's going to happen with this now. So it will show me now that I have total 4 partitions, 0 to 3, as you can see in this particular output as well. Question for you. Okay. When you will do this exercise, what will happen here is that what will happen basically to the data? Is it going to be automatically moved, or my partition 3 number is going to be free right now? That's the question which you need to answer. Okay. So you can check it from your UI also, and from there also you should be able to give me the answer. Okay. Now all of you have to do this exercise. Also try to delete a partition. Meanwhile, Arun, can I make you the host for a minute? Maybe once I'm back, you need to just make me rehost.
Yeah, sure.
Sure. I'm just restarting my laptop. It will take a minute because it's a Mac, but I'm just restarting and rejoining back. Meanwhile, you guys just complete this. Okay, Arun, I just made you the host now. Okay, I'm just restarting. All of you meanwhile do this. I'm just coming back in a minute. Okay, I'm back now. Arun, can you just make me host again? Okay. Meanwhile, you guys can keep on continuing doing your exercise. Let me just quickly log into my connectors. Once you're done, just type in the chat box you're done.
Hello.
Yes, ma'am. What you're saying?
Laptop is hanging too much. I have 16 GB RAM.
In 16 GB also it's hanging for you?
Yes.
That is sad, but it should not ideally. Are you running some other process by any chance? Anna, are you running something else by any chance?
No.
Oh, then it's
Docker, Notepad, CMD, Chrome.
maybe you can try to quickly restart if it's required. Because even I did that and now it's fine. Even for me, it's 8 GB, right? So it's definitely Zookeeper and Kafka eats up a lot of your memory.
Okay, we'll try.
Okay, now unfortunately I have to again wait for this connector to be up. But anyway, till that time we have some activities to perform. Once you guys are done, just ping me that you're done. So I can only see the fresh chat. So in case if you have written it during that 2 minutes time, you can rewrite it again. And not just done, also answer me that what are you seeing in basically the new partition? Is it something which is transferring the data and back, or is it a blank? You can check it from a UI port, right, from here as well. Newly written data. Okay. What about the older data? Aditi, what about older data? Anything happened to that?
Shivank, it was empty as far as I saw, like only new data I saw.
Perfect. Perfect. That's the right answer. Everyone else also quickly finish it. Maybe 2 more minutes. Karthik, what about you? Your laptop got fixed or still slow?
No, it got fixed. Creating cluster now. I got like I'm using two laptops now. So
So using
I'm
two
hopeful. Yeah.
laptops, that's also fine. Nice approach. Aditi, by any chance your Kafka Connect UI is working?
Let me just check, Shivang.
Open your terminal and keep it open. In case if in my it will take some time, I can show it on your system then.
Okay.
Because it sometimes do take 20 to 30 minutes to connect.
No, Shivang, it still shows that connectors thing. Oh, for Manju, it's working.
For which one it's working? So is it showing you something like connectors, one connector or something like that?
Yes, it is showing exactly like this.
Not this way. It should have some number. Yeah, like 1, 2, 3, 4. But till the time,
No, it's not showing.
yeah, that means it's still
For
waiting.
Manju, it is showing up. Manju, can you see?
Manju, can you confirm?
Yes, Shivank, it's showing connection is up, and it is show sources one source and the topics one. It is showing that.
Okay, just keep it open then and keep the code downloaded with you. In case if it takes little more time, I will show the code in your laptop. So I will tell you what all you have to do. It's a very basic step. And
Thank
once you do, yeah. Meanwhile, maybe by any chance it may come up also, but it's again due to 8 GB RAM, it takes more time. Okay, guys, now I need your attention back, all of you. So now as a next step, what I'm going to do? Now I'm going to use something called as Kafka Connect. Now what we are going to enter to. This producer consumer, what you just saw using the command line, it is okay to use like that. But in the real world production application, we don't write it like this, right? It's you need to write a Java code. Why we basically have to write a Java code? Reason being because your connectors could be multiple. Maybe you want to connect with Cassandra. Maybe you want to connect with Twitter. Maybe your producer is connected to maybe HBase, right? Like this, a MongoDB. Now, what's the problem with this? The problem with this is that using this command, which we have just seen, it will definitely not work because with this command with console, you can maybe do some basic operations from the console to console window. But getting a data maybe from MongoDB, Redis, or from those systems, how to bring them now? For that, we have something called as producers and consumer Java code. People were really happy with that. Everything is fine. Using the Java, you can create connections. But again, you need to learn Java for that. Now, what people came up with, they said, okay, fine. If I look at Kafka, we mostly have the common connections. Like either we are bringing from Cassandra, or we are bringing from SDFS, or we are bringing from Twitter. Like this, we have some specific connectors which we use. Maybe I'm bringing it from a file also, right? Maybe just from a simple file and transferring the data. That is also feasible for me. Now, in that case, if I have fixed number of connector, why I should rewrite some code? So for that, what people did was they started writing the basically some connectors for you, which you can directly start reusing it. Means you don't need to do anything for that. You can just directly start using it just like that without writing a single line of Java code. And that is what is called as Kafka Connect. Now, from the producer side also, you have the connectors available. From the consumer side also, you have the connector available. So for both the sides, you have connector available. And basically, you have to just call inside your connector some properties file and all, and it starts working. It is so simple now. And that's how you create those pipelines, like producer side, you're bringing data, consumer side, you can transfer data and so on. You can do all this. Now there are two type of environment also for us. Number one is called as standalone environment for Kafka Connect. That standalone environment is mainly used for production system. Like if you're working with only one machine, then it's fine. Distributed system is mainly used in the production side. So it's like that is called a distributed environment. Okay, so standalone distributed. So distributed is what we use in the production. It has a very minor difference in terms of code. There is no difference as such. Okay, it's very simple, but we will be also using here, and we will be seeing how to transfer the data. Now, for now, what I'm going to do, I am going to now transfer my data using a file stream connector. Okay, so how I will be doing, what I mean by that, I will be transferring the data using a file. So I will have a file. In that file, I will be sending some data, and that is using that file, I will be basically transferring the data whatever I need. That's what I'm going to do now. So how I will be doing that? Number one, I should be inside my connector, which I am right now. Now, what is the next step? I need to now, so let me also show you from these steps so that you are clear that what I'm doing here. Look at this one. So what I have to do as a next step, let me both open together. Okay. So you can see I have written each and every step here so that you don't get confused. I'm matching each and everything for you all together. So here, what I have to do, let me go inside tutorial. Okay. So tutorial. Now inside tutorial, if you look, I have the same code which I have, right? Even this YML file and so on. But what I want to do is, I want to go now inside a source directory because this is my source related data. That's the reason I'm going inside my source directory. And inside source, you can see I have 3 demos, which I will be showing you. Maybe one demo I will show you, 2 you can do it. I will explain you that. So now I want to go inside demo 1. Okay. Now, once I'm inside demo, I have some files. I will explain you what are these files now. So first of all, if you notice, I have this file called as demo file.txt. Let me see by chance if I have any data inside it. Yes, I have. So let me remove this first. I want to make sure that it's an empty file so that I can transfer my data. Fine. Now if I do a cat this is empty. Okay. I have no data right now in this. Now what I will be doing in this, let me first explain you what I'm going to do. Using a Kafka connect, I want to transfer the data. Whatever I'm going to write inside my demo file.txt, the same data should start getting reflected in the topic. Okay, what I'm doing is, so right now when I use the, basically I was writing the producer command, I was writing everything into the console, right? I said, hello, Shiba, big data. So that was inside the console window. But now what I'm going to do, I want to use Kafka Connect, which should be able to connect with my file first. And using that, it should be able to, whatever I'm going to write in this file should get transferred to my topic, whatever topic I will create. Okay, that's the step I have to do. Now, first demo which I'm going to show you is going to be related to your standalone. So basically on the standalone, because I'm working on a single machine also right now. So now what I will be doing in this case. So definitely I need a topic right now because without a topic, what I will do. So this is the topic. You can see demo 1 standalone. Remember, I removed that because before your class itself, I tested all of them. That's the reason. So now let me come back here and let me execute this. So what I'm doing now is I'm going to create a topic called as demo 1 standalone. And I'm saying that, okay, partitions are going to be 3, replication factor is going to be 1, and my zookeeper is running on this. We are well aware of this command. So let's execute it. Let this complete. Okay, this got completed. You can see I got demo 1 standalone. Even if from my UI also I can go and check that, and it's empty right now. Okay. Now what is the next thing? I have 2 files. Let me show you both of them. So inside the demo 1 itself, I have 2 files. One is called as worker.properties. Let me open that. This worker.properties file is only required when I am working basically on my standalone cluster. When I'm going to work on my distributed, I don't need this worker.properties. I have one more file, which I'm going to call it as file stream demo. You can see this file, right? So this is going to be my another file, file stream demo standalone.properties. Let me explain you both of these files first. Now in this file, if you look at it, what I'm doing is I am telling it that the name of my application is this. I can change it also to whatever I want. Let's say I want to change it as maybe just name it as demo standalone, or maybe just file demo standalone, right? Whatever name I want to give, I can give. Now what is this connector.class? So right now, since my Kafka Connect is installed along with Kafka, so what's gonna happen is basically all this is already available here. Basically, file stream source connector is already available for you. Somebody else have written this Java code. In fact, I can show you also. We can go here, copy this. I have given this link so that if you want, you can anytime check this. You can go to this GitHub. Okay, just happen. Looks like this person have removed it, but in the morning it was there. Anyway, this is fine. It will be available somewhere. You can see this file, right? This is a Java code written by somebody. You can see file stream source connector again. And here, get this, allow me a minute. Okay, I'm back. Sorry about that. Now here we can see that this code either you have to write, but you don't want to. Somebody who have already faced this problem, who might have just wanted to maybe transfer a data from file to maybe his topic, he might have written this code, and I'm just gonna use it. I'm not bothered about how it's written or what is the Java code. I just want to use it. Now, if you look at this, there are two entries required. One is a topic name where you want to read it, and some file configuration, right? Maybe your file name. So what I mean by file name, if you look at this one, come back to this, you can see here that basically I am telling here what is my file name. What is this file name? Remember, I told you that one file which I made it empty, right? This one. If we come back here, remember this demo file.txt is what I made it empty. So what does this mean? From this file, I want to transfer the data, number one. Now, where I want to write the data, I want to write it on demo1 hyphen standalone. That was the topic which we have created. So from this file, whatever data will be there, I will be writing it here. That's the number one. Now, if you look at this, what I'm also doing here is, if you see here, we are also using a connector.class. So basically this class is nothing but in your system, basically this file stream source connector is by default available to you in this container which I've given you. And basically that's what you are just providing the path for. That's it. This is calling the class name. This is a task max is equal to 1, which means that how many parallel tasks will run, just like mapper run. Similarly, how many parallel tasks will run, I'm making it 1 right now. You can change it if you wish to. If we have more cores, it will work. But if I will do it, it will be more time taking because it's my system already have lesser RAM. Now, so that is one thing we understood about this properties. Let's go to worker.properties. Now, first of all, any question on this part from anyone? Any question on this part from anyone? Everyone clear on these 4-5 properties? Okay. Come back to worker.properties. What is this? First, we are telling that where are my broker setup? Then after that, look at this one. This is going to be important. One is your org dot, which is I'm using as key converter. What is we are saying is that even if you're reading the data, let's say from a text file, but in the topic, how I want to write my key. So even if I'm going to read, let's say hello, but that should get converted in the JSON format. Okay. So I want to, if I want to do that, then I will say org.apache.kafka.connect.json.json converter. So what this is going to do, this is going to tell me that, okay, go ahead and convert my data to my JSON. Okay. My key should be converted to JSON. Now, but one thing, if I make the schema enable as false, then above command will not work. So I want to show you two flavors. Once I will make the schema as true, and once I will make it false. Okay. So now, currently I'm making it false, means I want to write the data in the text format only. I am not bothered to convert into JSON format. Now, since JSON have a key value pair, it's the same we are going to do with the value converter. Now, if you are working on the standalone system, then only this setting is required, that you have to also give the internal .key.converter. This is basically used for the internal purpose. Okay, so basically what I mean by that, you will not be doing anything for that. For running this command, this is getting used internally. And again, we always give it as a JSON converter if you have to provide. Okay. Now, after that, what is my REST port? This is mainly if we want to hit some REST command. I will show you them also. For now, it's not required to understand. Where I'm running it, we know it, right? 127.0.0.1. I'm running it here. Offset.storage.file name, standalone.offset. What do you mean by this file? So what happens is, let's say you ran your producer once and then you closed it. Okay? You stop that. Then what it will do, it will create a file called as standalone.offset. Think of it like a checkpointing in Spark. And what it will do is it will store that till what point it have already read it. So next time when you send a new data, now it will know that, okay, I need to start writing it from here. So this is like a checkpointing what it have done. And your flush interval millisecond is 10,000. Basically, the checkpointing should happen in this millisecond time frame. So this is about your worker.properties file. Now what I want to do with this. So what I will be doing here is, I want to now come back to this source.sh. Let's come back to this because we would like to execute this command as well, right? So now what I will be doing, I will be executing this command, which I'm saying as connect -standalone worker.properties. And I want to, so always worker.properties should be first. And then after that, my second properties file, which we have created. We have created two files, right? So I'm going to give these two now. Let's see what's going to happen. Now let me execute it. Okay, so it has started working now. Right now, there will be no data inside this, right? There will be no data which is going to be present inside this. So you can see it is doing some more activities, info, standalone configuration values and all that. It's running actually internally, it uses the Jetty server. That's what it's showing you as Jetty. It's similar to Tomcat and all that, but there will be no data currently inside this because this topic have nothing right? It's all blank. So now what I will be doing is, let me quickly basically doing something. Let it also complete because we need that. Let me also open my consumer file. Just allow me a minute. And by chance I forgot to write it here. I want to show you one more command. Anyway, meanwhile, I'm just searching that command so that I can show you. It is still running, so we have to wait anyway for this. Actually, I don't want to open a new terminal because what happens is then this takes even more time. But okay, anyway, I think we don't have choice. There was a command which I had written for it, but it's okay. Let me just quickly. Let me see how many Dockers I have. So this is my Docker, which is running for the last 24 minutes. And I have this as, not this one, this one. let me take this one. And what I want to do is I will say Docker execute. I want to go inside it actually. IT might be bash. Okay. Now what I will do here is let me send some data to my demo file.txt. But right now, if you look at it, my this one will not have any data. For example, if I come here, do an enter. Now, if you see, this is the one. Right now, there is no data inside it, right? It's all blank at the moment. Let's see this. So it's all blank right now. Now what I will be doing here is, let me go inside my folder again, which is going to be tutorial, ls. I want to go inside source, okay, ls. I want to go inside demo-1, do ls. Now what I will do is I will write this data here on my demo file.txt, and let's say I say hello. Let's close this and let it write. Let it write. Allow me some time for it. Let's refresh it. It's taking some time. Again, my system is started responding slow. But once it will be done, it will be writing the data here. Okay. It will show up this data written up here. It's just taking some time. Okay. Meanwhile, can you all basically try to execute it at your end? Okay. Just make sure that you write this data inside this file. Okay. Demo file.txt, which is inside the container, not in your local system. If you will do that, it will not work. Okay. It will take maybe a minute or two because it's little slow. But once it is done, it will basically bring the data here, and that's all happening because of your file script. All of you work on it. Looks like Manju, I need to use yours only because it's still taking so much of time.
Okay, sure. I will share.
In fact, guys, let's do one thing. Since we are left with last 1 hour, let's start working on the remaining things up. Maybe you can try this up because I will give you all these detailed things which I just showed you in the atom editor. Okay, you can try it out after that. You will be able to execute each and everything because this is all tested code. Whatever I have written, I have basically tested around everything on the system. So you can execute it as it is and it will work in the same way. Okay. So let's do the second thing now. So what I want to do is now I want to show you the file stream connector in the distributed mode, how we will work with the distributed mode. So let me first show at my system whatever I can do that, and then I will give the access to Manju and he will basically do the same thing for me. Okay. So that you will be able to see what all activities are happening here. So first thing first, I need to create, first I want to go inside my container. Let's exit it from the older one. Let's exit it from here. Let's again quickly connect with this. Manju, you can also do this part if you want and create a topic, which is going to be demo2 - distributed. Okay. Once you enter inside, just exit from your container so that everything is running, it can get stopped. And let me close it here also. I don't need it. Yeah. Now I just created another topic called as demo2 dot this part. Now what I have to do as a next step. Then after that, I need to come here, which is currently still not on for me. It's taking time and I think it will take more time because I open one more terminal for it. So maybe I'm just making Manju now as the one, but before that I can explain you at least one step. So what I will be doing now, I will be coming now to my second demo, which is demo2. Okay. So what I mean by that. Here we can see this part, right? Earlier we did demo1. Now I will go inside demo2 and here I will open this. Notice this thing now. Let me explain you first what is this. So this file is name, which is named as demo distributed. I'm giving this connector.class, which is going to be my file stream source connector. I'm giving again one max. I'm giving this file name, which is demo file.txt. I can give some other file name. You can change it if you wish to. Then after that topic, we have just created this way. And notice I'm only giving key value pair, which is JSON converter. And this time I'm making schema as true. That is going to be interesting what I will show you now. But notice this time there is going to be no worker.properties file. Okay. Secondly, there is no internal.converter also because it is no more a standalone mode. Only in standalone mode only you don't need this. But how you will be doing this now? So first thing, Manju, just unmute yourself now. Can you see if you can share your screen, number one? If not, I will make you host. I'm stopping my share. Perfect. It's working for you. Awesome. So what I want Manju to do, you can unmute yourself so that we can keep interacting.
Yeah, sure.
Okay. Now, can you go to the UI connector first of all? Go enter inside the Kafka Connect UI. Perfect. Now click on new, which is on your left hand side. Click on new. Now look at this, guys. On your right hand side, you see all these connectors. For example, you can see Twitter connector, Yahoo Finance, file, and so on, right? So all these connectors are by default available for you through Kafka Connect. Now here, I want to transfer the data in the distributed mode using the file. Click on that. File. Yeah.
Where file?
Just click on this. Perfect. So now you can see it is also giving us some few things, right? It's saying that name is this, connector is this, task max is this, file is this, topic is this. Can you see we got the template which we were looking for? But let's not use this. Can you go now to the demo tool? Go inside your demo tool. Okay, you have already opened it. Copy paste this. Copy this whole thing. And just remove this and paste the part. Now remove all the hashtags. Remove all the hashtags. Not just hashtag, means remove the whole line because these are comments, right? I don't need it. Remove this whole line.
Where in fifth line?
Yeah, first line, fifth line, remove it completely. Completely remove it. Yeah. Remove the fourth line, which is parameter cannot be found and all that. Remove this. Remove the space. Yes. Fine. Now, once we have done this, click on create. Okay, one more thing. Have you created the topic?
Yes.
Okay. So can you also undo or okay, don't do the right thing. Can you go back to your UI? Not from here, the second terminal. The second tab, I think the first tab you have it from this, right?
Yes, I'll copy this.
You have how much time? Only give 127.0.0. Okay, just click on Kafka Connect. Click on Kafka Connect, the top side, left hand side. Yes. Go to topics. Topics. Enter. Can you see this demo? Just open this. Click on this. So right now you see all that it's empty. There is nothing present inside that. Right? It's all empty for you. Now, can you go to Kafka Connect UI again back? Now from here, click on create. Now, can you notice on the left hand side, there it is written as file stream demo distributed. And can you hover over it just to show to everyone? Left hand side, file stream demo distributed. Yes. And it's saying also on the right, file to Kafka, right? It's sending the data file to Kafka. Click on it. Now notice it is saying that Kafka is running, right? It is sending some data. Now can you go back and open your file text demo file.txt in your container. We can't see anything here. It's all blank.
Yeah, it's
Just don't close it. Don't close it. Okay, this is consumer. Fine, fine. Then it's fine. Yeah. Can you go inside the directory /cd tutorial? Do cd tutorial? No. Why you are doing slash? Simple cd tutorial. No,
I
why
think
are
I
you
created tutorials, I think.
It should have copied, right? If you have logged in the right way. Can you do an ls?
I think.
Yeah, it's there. No? Do a cd space tutorial. Do an ls. Okay. Now can you go to cd source? In fact, I think we even don't need to do that. That should also be fine. Can you do just cd? Just type only cd enter. Should be fine. Can you say touch demo file.txt? Touch space demo hyphen file.txt. Now insert some data inside it. Just save it. I think should be fine. Fine. Now go back to your UI. Refresh your topic. Go to topic one. I think the next tab. Next tab. Yeah. Refresh it. It is taking time. Okay, then we have to wait for it for some time. Anyway, we will see it in few minutes. So what will happen here is once the data will come up, it is going to be in a JSON format. It is not going to be into your normal text data. Though he have written hi, hello, but once the data will come up here, you will see it into a JSON format. That is what your schema true is going to do for you. First of all, everyone clear on this part? How this whole thing will work? Any question on this part from anyone? Okay, that's how you will be transferring your data from the distributed mode. Let me show you one more thing quickly. Now, can you go to, can you create a new topic, maybe demo3 Twitter? Manju, just open that file again, that source.sh. Yeah, the last file, okay. Last file, just open this file. Now here, can you come down? Come down? Yeah, from here, you can see the last one. Can you create this Kafka topics I can create? Let's create the third one called as demo3 Twitter. Just want to show you how we will work on it. Later you can try it on your own. You just hit only this much, correct? Okay, now you have created this folder, right? Now what we will do is, can you go to your demo3 folder now? Demo3, open this file. Now let me explain you what all we will do here. Look at the first one. Name, we are giving something. Connection class, I'm using Twitter source connector. One task at a time. Topic, we have just given. See the key converter, value converter, all same. Schema is enabled. That means it will come in the JSON format. Look at the remaining value. Can you remember yesterday we have discussed about all these 4 values, right? Now, whatever values I have kept it, that will not work. Okay. This will not work. You have to create your own app and work on it. I have already deleted that. This is only for testing purpose. I created this. So after testing, I've deleted this. So now those four values, you have to fill it from your app. Then after that, what is the track terms? Basically, if you don't put it, it's still fine. But in that case, your machine will get filled up with data. Okay. So don't do that. So I have just put down some 4-5 keywords, like if in the tweet it finds programming word, Java word, Kafka word, or Scala word, then only it will bring that data. Then after that, language is English. Otherwise, it will start showing you Korean, Chinese, all that tweet also, and you will get confused with that. That's the reason we have used language as English. Can you go back to your connector UI now? This is the topics. Go to the second tab, Kafka Connect UI. Click on new. I just want to show you how you have to do it. Click on Twitter. So this is the way you will be working on that Twitter side of the things now. So now what you have to do is, once you have this file ready, the demo3 one, you have to copy paste here. Okay. Now don't do it because anyway that keys values will not work for you. So once you will be having your own app, you have to copy that file with your SS key and SS value and click on create. That's it. Your topic will start getting values from your Twitter. That is something again will be in the key value format, and you will be able to do that. Guys, you have to make sure that after this class you do this. In case if you struggle with anything, feel free to drop an email. I can give you my mail ID also. You can connect with me. I will be pretty much fine with that. But ensure that you all basically do this steps. Right now, due to the lack of time, I'm kind of just telling you what to do, but I have already made all the detailed notes for you to follow. So right now I showed you 3 sources, how it works with it. Okay. Now, can you take me to the another file, which is the sync one? Can you open that second file? Anju?
Which one, Shubham?
Yeah. So you have opened source.sh, right? Can you open the sync.sh now? Go back. Yeah. Open the sync now. Go again to that folder. Go back. Go back. Go back. Yeah. That last, second last. Perfect. Now, in this case, I'm using the second Docker. Remember that YAML file? Can you open the first file, docker composer.yml, which is in your first tab? It's already open in your first tab. It's already open. Yeah, this one. Can you notice the second, which is on line number 19, Elasticsearch, right? So now I want to basically, what I want in my sync is, I want to send my data in Elasticsearch. Anyone who do not know what is Elasticsearch? Or in fact, who all knows about Elasticsearch or have worked on it? Anyone who have worked on it? No one?
Yeah, Shivank, I did.
Okay,
Hello.
Girish. So, Girish, for what purpose you have used it?
So it was basically used for searching and indexing of data.
Searching and index, correct. So basically it makes the searching like really fast. If you have like very huge data out of which you want to query something, it creates your indexes and it works like really fast on top of it. So here what I want to do is, since I have to also in my container Elasticsearch, that's the reason we need to have an image which requires Elasticsearch. So as you can see here, I will be using Elasticsearch image. Now go back to the sync.sh file. I think it was already open. Fine. Now, so once you will be having it, now the same way, line number 8, as you can see, Docker compose up, Kafka cluster, Elasticsearch, Postgres. So here I also wanted even the Postgres inside the same one. So that's the reason I've done it like that. So it will on your cluster now with respect to not only the Kafka cluster, but also I need now the Elasticsearch also within that. Now, once you will be done with that, then after that, this command which you're seeing on the line number 15, which is http 127.0.0.19200. If you hit this, and it will give you a JSON file in your browser, that means your Elasticsearch is working. Okay, so once you have made your Docker Compose up, once you hit this, it will show you that okay, my Elasticsearch is working and everything is fine. You can try it afterwards again. Like I said, I'm just explaining you right now these steps. Now, once this is done, then after that, what you have to do, you need to now start working on your sync folder. Go to your sync folder. Sync folder. You already have that open there. Yeah, same. Now go to the first one, demo Elasticsearch. Okay, open the last file. But look at this file. Again, the same style. Name, connector class. We are giving how many tasks? Actually, this is going to be bigger. That's the reason I took 2, but you can make it 1 in case if the system works slow. Topic. So we have to again create the topic, which we might have done it before. So in this case, I will be using the same topic. The Twitter data which we have got, actually on top of that only this Elasticsearch is supposed to work. Then you can see the key converter, value converter, all things are same. I'm only telling what is my connection URL for my Elasticsearch. Type dot name, basically what's the name of it? It's going to be Kafka Connect. Key ignore, this value you can ignore it. This is basically sort of for the Twitter, you are getting the data in the key value format, right? In the value you have the actual key. So ignore that key portion of it. Then we are just telling that some values related to Elasticsearch, like we are just saying schema, you can ignore it, which is true. Key, you can ignore it. Index mapping we want to do. So I will show you what you mean by index mapping in some time. Now what you have to do, go back to your Kafka UI. Now click on new. Now, can you bring it down? Bring it down. Bring it down. Yeah, this one. Can you see Elasticsearch Confluent? Open that. Yeah, this is also fine. This is also fine. Last one also I can click. Anything is fine. Yeah, both are same actually. So here you have to copy paste this. The same thing which I showed you, you need to copy paste this. Once you will copy paste, click on create. Now what will happen is all your data which is there in my Twitter, which came from Twitter, basically part demo 3 Twitter, it will read it and load all the data into the Elasticsearch. Now, can you again go back to that sync.sh? Not this one, yes, correct. So now here, once the data is loaded, the 22 line number, which you see here, once, 19 line number, when you will click on it, it will open the UI, which will have your Elasticsearch. Now people who know about it, this part really well, they might be knowing how basically my Elasticsearch UI looks like. First thing is you need to give the name of basically of your name, which you have given in your SH file, which was there from sync elastic Twitter distributed dot properties, right? Whatever the name you have to provide it there, you can drop down, you can select it out. Then after that, what you have to do, can you open that folder again, which is a sync folder? Sync folder. Yeah, yes, same one, same one. Open it again, demo Elasticsearch. Now open the first file, which is a JSON file. Now, people who are coming from Elasticsearch, they are well aware of these queries. If you are not aware of it, You can just skip it out and nothing to worry much here. So what it will do is, I want basically the people whose friends are more than 500. Okay, this is what this query means. So now from Twitter, I got so many tweets, but I got so many of the details also there. So I want basically the friends count, whatever, how many friends are there who are greater than 500. If you hit this query in the query panel of Elasticsearch, it will give you all the results belonging to it. Can you go back again to the sync folder? Open the second one, query only routine.json. Now this basically means, this again we are going to hit in the Elasticsearch UI. This basically means whatever tweets are retweeted. Okay, so there will be also a metadata which will come like, okay, this tweet is retweeted. So it will say is retweeted as true, which means that this tweet is retweeted tweet. So how many tweets are retweeted? So basically I want to only print the retweeted tweets. So I can hit that and it will give me very fast results around it. So this way you can play around basically with respect to all your Kafka components with your connector as well. Any question on this part? Any question on this part? In fact, Girish, do you have basically any lab or cloud where you already have Kafka set up for your team?
I don't think so, Shivan.
Because I do understand this Docker or any event, they will try to run it on their own system. Kafka eats up a lot of space.
But I'll try to check if we can set up an EC2 instance and install Kafka. If that can be done, I'll check with the IT team.
Yeah, otherwise just see EMR also you can try that have Kafka.
But EMR is a bit costly, right?
Yeah.
Than EC2. Yeah, if the cluster keeps on running, then the cost will add up.
That I agree. I think then if you can set this up and make them run this, I think this is going to be very important. They should definitely try all this. Just that if you can track it as a lead on this part, so that they get all this practice answer.
Yeah, I'll take care of that. But even we have this service called MFK, right? Manage Kafka Service.
Mm-hmm.
There's a service on AWS, right? MSK or MFK. That's a managed service by Kafka.
That also you can do that. It's anyway is fine. It's just that if you can ensure they do practice on this, that's more important.
Okay.
I'm also okay in case if anybody like everyone in the group is facing issue around us. Maybe I can set up a call with you guys for 15 minutes, can show you up. That's something I can fix it up. That should not be a problem. Okay. Because AWS and all, even I have used it a lot. So that's not a big problem. Okay. Now, one thing is we just understood about how to work with this. Similar way, you also have PostgreSQL. Now, have everybody seen there is a pattern? Every time there is a same pattern which we are following up. And using that pattern, we are able to just execute everything, whatever we want. We created a topic. Once we created a topic, we have a dot properties file, especially when we are working on distributed mode, it's more simpler. We created a dot property files. We put all the details corresponding to it. We went to the Kafka UI. From the UI, we select that connector. We pasted that property swipe. We click create and done. So anything you want to do, you can easily do that. So one homework, though I have already written that code also for you, but one homework, you can actually try to whatever this maybe Twitter demo we have created, you can send that data to your maybe PostgreSQL. So that you can try it out and see how that works. That code is also available for you. You can look at the code, it will follow exactly the same pattern for you. Any question on this part, guys? I know there is a lot of homework, especially from today, which is coming up. Manju, maybe you can stop your share now. From here, I can take it up. Yeah, I know there is a lot of homework for you for today part till this step, whatever we have discussed. So, yeah, but any questions till this point? Guys, feel free to ask your questions. And actually, whatever we have covered, it's not like it's like complete. Like I said, there could be Kafka string. I think, Grish, you have asked this question, right? When to use what? So generally, if you're transferring a data just from Kafka to Kafka, then go for stream Kafka stream only. It also do it like row by row operation. Just like in Storm, if you're aware of Storm, that also do row by row. So it's little different from your specifically when it comes to Spark string. But whenever you want to do some processing, basically once it comes to your SDFS or wherever you want to bring it up, then in that case, you should always go for Spark streaming. That is, in fact, I always prefer to connect Kafka with Spark streaming and do my operations. I think somebody else also asked one in middle when I said we have not even started Kafka. I think somebody was asking about Confluent Kafka. So you can think of it, it's Confluent Kafka is also just written on top of Kafka only. But at the same time, it has some extra functionalities. You can also do some processings on top of it. That's the reason if you want to go for premium for it, you have to pay for that. So it's not like for a lot of supports, you need to go for payment. Basic things you can run it there. Any other question before I start one more thing? Okay. Now, this you have to just try it out after that. Let me tell you a few more tips which will be helpful for you in the long run. Now, like I told you, there are few things. For example, now Hadoop 3.x came up. Then what should I go for? What will suit my requirement? If you can go for Hadoop 3.x, then take it up. Reason being, when we talk about the storage overhead, right? In Hadoop 3.x, there is something called as eraser encoding. You can go and read about that. There's a lot of things within this. Basically, it's more related to 3 parity bits and all. And if you know about something called as RAID, which is RAID, it is similar to that. So using that encoding technique, it have reduced the replication load for you. And still at the same time, it is giving you all the fault tolerance. Okay, this is a very smart technique. Even Facebook uses it for a lot of their internal systems also, this encoding. And if the overhead in Hadoop 2.x is, let's say 200%, I'm just taking an example, then in Hadoop 3.x, the storage will be 50%. Okay, so think of it, just to give you an insight, it works like you might have done that bit theory, right? Binary theory, like 0101, right? And you do some XOR operations and operations on that. So it keeps the data based on it. So it will transform your data from something to something else. And from that, when it reads, it basically will be able to pull out. But if you miss out any of, if you lose out some of the data, it will be able to retrieve it. So it works something like that, but read about it if you want to. It's the very special thing which came in Hadoop 3.x. So your storage cost is getting saved a lot in Hadoop 3.x. Second thing is, when it comes to file system support, if you're using Amazon S3, you're using SDFS, FTP file servers, maybe even if for Azure, if you're using the storage blocks, fine, Hadoop 2.x is good with that. But let's say, if you want to connect with something in Azure, there is very famous thing called as data lakes, more related to big data again. If you want to connect with that, Hadoop 2.x do not have the support. Okay, so there are sometimes the client come up and say that, hey, my data is sitting in Azure data lake. Now, how I work with Hadoop? Because they can't get the data. It's not easy. Actually, there are a lot of tricks which you need to play with that to get the data. So that's where Hadoop 3.x again help you out. I'm just telling you these tips because these problems I have myself faced across from the clients. Even when it comes to load balancing, Hadoop 3.x is actually better. It does much faster because it uses something called as intra-data load balancer. On the other hand, I talked about something called as SDFS load balancer. Intra-data load balancer, if you want, you can again read it up. This is far better in comparison to Hadoop 2.x one. which is SDFS load balancer. One more interesting thing which I already told you, when it comes to Hadoop 2.x, there is no support for your GPU. On the other hand, you will get this support when it comes to your basically Hadoop 3.x again. Okay. Even Hadoop 3.x, if I'm not wrong, yes, they also have the namespace, which is also kind of coming up. On the other hand, again, this is a problem with your Hadoop 2.x. Now, one thing keep in mind, if you are working with Hadoop 3.x, Java 7 will not work. Okay, so that's one thing you have to keep in mind. Don't miss it out. Otherwise, you will keep struggling why my Hadoop is not working. And mistake is not yours. It's basically the mistake is happening because of the version not supported for it. Okay, that's something again you have to keep in mind while working on this. One more thing which I want to talk here is sometimes people say that, okay, should I keep my data in SDFS? Let me take one of the cloud, let's say S3, Amazon S3, or should I keep in my Amazon S3? Where I should be keeping my data, where it will be better to keep it. Now, it depends on your business problem. Because it's not mandatory that you only keep the data in SDFS and then only you can read it. Like, if you remember, when I showed you Spark or when I showed you Hive, I already showed you, right? You can load the data from anywhere. It's not mandatorily SDFS. I showed you that I can load it from a local system also. So that way, why even I need SDFS? Right? So few places, yes, it will be helpful. Few places not. Number one, when you're keeping in SDFS, it goes to your local storage, right? So maybe if you have created, let's say, SDFS on some EC2 machine. So in that, basically, whatever the local storage is there, there the data is stored. You can very easily scale and all that is all good, right? Even you can keep adding more machines and storage. But if you want to add, you have to manually kind of go and keep on adding. So what I mean by that, when I do horizontal scaling of some systems, definitely I need to do some configurations, right? It will not automatically just come up on the fly. That's something in SDFS you need to configure. But when it comes to S3, S3 is more of a global storage. Now, when I say global storage, people who are from cloud environment, they must be aware of it, right? So it's like you can access it from anywhere. Now, what happens is maybe I'm sitting in India, maybe one of my team is sitting in US, and maybe one is in France, wherever. So in those cases, that global storage may be a better idea. I want to just quickly pull that out. I don't want to create those connections with the local machines and all that. That's basically works really well. Secondly, what advantage I see in S3, the major one here is when you have to horizontally scale something, it can happen automatically because of some load balancers and all which also is there. But S3 have this flexibility that it will automatically can scale infinitely. You need not worry about that. So that's one advantage what you get again with S3. One more thing is you might have heard something about durability, right? So my data should not be lost as such. So when you're talking about basically SDFS, yes, we have durability in terms of we can say that, hey, I want replication as 3 and my data will not be lost, right? It will be all fine. But when it comes to S3, if I'm not wrong, they provide the durability till 9 numbers. When I say 9, means 99.9999 till 9 times. Okay, so which is very huge. It is equivalent to like multiple replications. So it's almost like saying that it's maybe very rare to lose the data. So it's more kind of durable in comparison to SDFS. So again, here also I say that Amazon S3 is better in comparison to SDFS. Now, second thing is when we talk about data also, right? A lot of times, let's say when I stop my EC2 instance where my SDFS is running, then in that case, the data which is sitting on that will be gone, right? Because you have stopped that EC instance completely. When you stop, that SDFS machine is not accessible itself. Maybe then it have to go to the replica copy and search it out. But in S3, that's not the case. It's never like shut down. It will be almost available, kind of related to your durable again, which is there for you there. One more thing, which is actually going to be very important, when it comes to storage cost. In terms of storage cost, your HDFS, if let's say, in fact, I can relate it one example of my client itself. They were paying somewhere close to $100 per terabyte per month basis. Okay, that's what they were paying. We just migrated it to S3 with some changes with that. When I say changes, there are some ways I will talk about that. we were able to reduce it to $23 from $100 per terabyte per month, which is almost equivalent to 5x cheaper in comparison to what we were doing with SDFS. So that's again basically thing you need to keep in mind. So Amazon S3 is cheaper in comparison to your SDFS disk because of EC2 instance and all that. So that's also again you have to keep in mind. And the same things are true for Azure also. Okay, I'm just taking an example of S3 so that just I'm going with some specific cloud. When it comes to maintenance cost of SDFS, then in that case, generally you need some Hadoop expert, right? Who knows about dealing with SDFS and all that and take care of it. And these are required because when you're working on, let's say, clusters which are of thousands and thousands of number, it's pretty huge. Now, when it comes to S3, you don't need to do anything. The cloud providers will be taking care of it, and it's very cheap option for us in that case. So again, S3 is the winner. Now let's talk about basically, like I said, it's whatever you want to do, right? In terms of elasticity, also I'm just thinking ahead from top of my mind whatever is coming up, so that you can basically get some advantage. So I think I already talked about horizontal scaling, right? In S3, it is very elastic. It can quickly go ahead with that. In terms of availability, also S3 is more available. If I'm sort of assuming that I have 3 replica, so that's more available in terms of that. Now, the cost, I already told you it's much cheaper. But one thing I want to talk about now, where SDFS is going to win. Okay, now listen to me very carefully here. When it comes to read and write, in fact, this is one experiment which I have done it on AWS M1 X large instance. Okay, so X large is pretty decent machine. And what I did there was I kept the S3 part. I was checking from there. I was doing the same. I was basically checking for the performance throughput in that case. What I found out was HDFS reading was happening with 350 Mbps per node. I mean 356 or something. I'm just going with a round number. Write was happening with 200 Mbps per node. On the other hand, S3 was slower. S3 was like 120 Mbps per node for read, which is in comparison to 350 is very less. Similarly, for write, it was happening for 100 Mbps per node. Okay? So if your throughput is the criteria, then S3 is not good. Okay, so that's where I said it's you have to keep this in mind, like what's your business case, and accordingly you have to take the call. Definitely S3 seems to be winner, but few places you have to see to that. Now, HDFS is also tightly coupled sometimes with a lot of applications, but on the other hand, S3 is not. You can decouple with your computation; it will go all fine. There's no problem with that. So again, you have to keep all these things also in mind. Now, when it comes to some transactional, right? Maybe you want to look at some data integrity and all that. At that place also, SDFS is better in comparison to S3. So I could, on top of my mind, I can recall these two cases where SDFS do better because I've already done all this experiments around. So when you talk about atomicity, it's basically SDFS is better in terms of transactional rights. There in S3 also you can achieve that. It's not that you cannot, but you need to write some application logic to do that. That's one thing to keep this as well. Now, S3 have one or two more advantages. For example, S3 provides you the backup and disaster recovery option, which is because of S3 is provided by the cloud and they do take care of it. Even you have something called as cross-region replication. You can put it into different regions very well, which is not there with SDFS again. Similarly, when it comes to the maybe the migration of your objects and all that, it's pretty good here. So people who are coming from the cloud environment, you must be aware of there is something called as cold storage, hot storage and all that, right? So a lot of times what happens is in my applications, maybe I worked on a data set, I am just keeping it. I don't want to delete it because I need it in future, but I'm not using it for now. And maybe I'm using some other data set right now actively. Now that data, which is basically not getting used, I would like to shift it to the cold storage and all that, right? So cold storage and all are very cheaper in comparison to this. So that's the reason when we do in this operation, it becomes much more cheaper, which is not an option with you when you're working with SDFS. So if you have some logic where you know in your cluster that this data set is important, but I'm not going to access it, you can easily do that in S3 to move it to the cloud storage, sorry, cold storage, and it will save lots and lot of cost. So when I said $100 to $23, now it may come down to even much more. Okay, so that's again an advantage what you get from the S3 side. So if you ask me what to use when, again it depends on the business application what you're looking for. Okay, so you cannot blindly just take up the calls that okay, I will be doing this way or that way. You have to take a call based on your demand, but most of the cases probably go with the cloud instead of SDFS. If throughput is specifically not a concern, disaster recovery is not a major concern, reading the data from global is not a concern, then go basically with respect to your S3 or maybe in Azure you have blob storage. Go with that. It will be much more cheaper. You will get much more advantages, and you will save, like, you will not realize, especially when you store like petabytes and zettabytes of data for clients, right? Especially if it's coming in the stream continuously for you, then the cost optimization is huge. You will not realize you will save sometimes millions of dollars. This I've seen it in the practical world. So when the daily basis you're getting zettabytes of data, like for example Facebook, this cost of optimization helps a lot. That's the reason all these big companies have already migrated to Hadoop 3.x. In fact, I myself work on Hadoop 3.x for Facebook. There are other companies where I work for Hadoop 2.x, but I have to start working because of demand in terms of storage reduction and all that also becomes important. A lot of places, they keep all these things together also. They say that, hey, I will also keep some data in SDFS. So some application will work on SDFS. Some data will work on S3. Some data will sit into my NoSQL DB and so on. Right? So depending on the application also they take call. Again, organizations keep setting all of that. And different teams who are handling that, they know their use cases well and they connect all these dots really well around it. So again, this all depends on how you want to use it, what you want to use it. And based on that, you should always take this call. Everyone clear on this optimization part as well? Any question on this?
Yeah, Shivanka. See, I have handled, like I have built data lakes for a couple of banking clients. These people are not comfortable moving to cloud. They always want their Hadoop ecosystem to be there on premise so that their data would be safe. So that was one scenario. But again, when we try to compare on premise with cloud, right? In cloud, I see there is a lot of opportunities wherein we can leverage all the services that are available, but that might not happen on premise.
One of my clients in a similar way. What happened with them was they wanted initially, in fact, this is with respect to InMobi. What they did was they have everything on premises, and generally they do it because of the data security aspect. That's the reason they do it. When the application started running and the cost was higher, they thought, can we optimize it? So first we built the whole application as they wanted, kept it running for them. It's completely fine. After that, when they started shouting about optimization, oh, our cost is so huge, we have to pay so much, then we suggested that, hey, I think it's better we can migrate it to cloud. Maybe I can show you a POC how your cost will reduce for it. Then I showed them a POC and then they said, forget about security and all, let's move the data there. Anyway, it's secure only. And we definitely, since they were little concerned, we encrypted the data also for them, especially the very secured one. We encrypted the data. But when we put that, it saved huge amount of money for them. So you can also take probably the same approach. Whatever client is asking, do it for them to make the system okay. And then later you can take all these calls as well.
Yeah, right, Shivank. Even I'm taking some couple of interviews as well. So people who have this big data profile, right? Most of them would be on premise.
Okay. So it's again depends. Nowadays, cloud is much cheaper. So you can save a lot of costing with that. But yes, a lot of companies are still not like very easy going towards the cloud. And it's actually a problem also, right? Sometimes if you know the story about how this Prime came in the market, so they have Netflix. So Netflix used to host their data on AWS. They noticed that okay, on this server a lot of activities happen from Netflix. They decided to open the Prime itself. This is a very interesting story. So that's where a lot of privacy concerns came up. So because these companies are smart, they even start eating your business, right?
Oh, okay. I knew this.
Yeah, this had happened in the past. So it was funny incident, but yeah, means they have never compromised with the data, but what they noticed what okay, this data is getting access so lot. It is such a big profit organization. So they also moved to the same one. So yeah, anyway, that's the whole reasons like these companies are very skeptical about giving their business. The same thing happened with Paytm also. If you have heard, Paytm is like what they do is they will add you first as a payment gateway, and then later if they see this business is useful, they will also open it. So what other companies will do, they will also always have this sort of issue whether I can trust these people or not. So yeah, you have to slowly make them convince around it.
Yeah, I never had challenges when it comes to other clients, but banking clients, they are very adamant. They don't want to expose their data to a third party company, be it Amazon, Microsoft, or Google. They want to have the data on premise.
I have moved the cloud data for SDFC Bank, some part of the data to cloud. So
Oh, okay.
they I made the move there.
And even I was going through this AWS Summit online that happened 2 days back, and there were a couple of banking clients, the ones in India, right? ICICI and yeah. So ICICI was the one who decided to move everything to cloud by 2024.
Okay, okay, that's pretty good. See, people will move slowly. Cloud is not very old also, so it will take time, but it will happen. So it's good if you have the mix of people in the team also, because you never know. Some clients will keep coming up and say, "Hey, we need in cloud," and if you have that skill set in your group, it will be very helpful in terms of people. There are not every company is constrained around that, so at least you can provide them a cheaper service. Show them the way we are giving you so much of optimizations and all that. Okay, so this is it, which I wanted to talk. I know it was a long journey we have taken in the last 40 years. I hope you all have enjoyed it in terms of understanding each and every concept. I wish all of you best of luck now for your projects. There will be few challenges which will be new for you, which will keep coming up. But since if your base is stronger, you can very easily kind of now go ahead and solve that. That's the reason I kept on bringing a lot of my own experience around it. I hope on the day one, which I said that this is one of my hobby, I hope you can make out why I said that, because that's the reason I keep on bringing so many things. And whatever codes which I have shown you, everything I will upload it by today evening. So you will have everything available, which includes some Spark MLab. And I think yesterday also I showed you some Spark streaming concept. I will upload all of that so that you can practice. So since you have the recording, I would suggest you can go back and review a bit here and there, and do this hands-on someone Kafka. Please guys, don't ignore that. This is going to be important. Okay. So any questions or anything from any of you?
Shivang, where exactly will you upload all these documents?
Google Drive, the same one which we are using.
All right.
Any questions, guys?
Shivank, in somewhere I saw the job description. There they're asking for data pipelines and CI/CD. It's CI/CD and data pipelines.
That is more like a continuous integration, continuous deployment, more like a DevOps thing. Yes, I know that is becoming now a de facto in this IT industry. Uh, Generally, DevOps are a different team, but now it is expected that everyone should know this Docker, CI/CD, and all of that. So the idea is just to give you an insight how those pipelines are created. Generally, it is used like some framework like Jenkins and all that. And what we do there is, let's say you just uploaded a code. Now it will automate everything for you. Like it will go ahead, test it for you, do some steps, send it back. It will build your code. If any error will come back, it will immediately report it back to the developer. So at every stage, it became sort of an automated, and that is what DevOps is also all about. Even I use it for a lot of clients now. Though I have a team of DevOps who kind of take care of a lot of stuff, but still all my developers also need to know across that what exactly is this in this manner as well. So yes, this is going to be one thing which you need to know. Maybe you can go through some DevOps stuff for understanding this stuff. Even this Docker is very important. Not Docker, I would say Kubernetes is more important, which is even a concept on top of this. A lot of times, even I have created a lot of Kubernetes stuff in big data ecosystem to get my things even much better way. Even I've integrated with Jenkins and all that to make sure that I do the continuous integrations quickly and get that to the right process. So yeah, it's more of a DevOps to answer you on this part. But yes, it will be good to you for you to know it because this is something which is now becoming a de facto. And if you know it, it will definitely help you in a lot of your projects.
Thank you. Thank you, Shubham.
So Shivang, did you know this instance where S3 service was down for a couple of hours? Maybe in the year 2017, I believe. I'm not sure.
It's happening, right? Not just 2017. Means sometimes the outage is for longer time, sometimes the outage is for shorter time. So, but I have seen these outages quite often because for me, the cloud services kept on running. And as soon as something goes wrong, immediately I get an alert. So that's how I get to know that there is something wrong in either Azure or GCP. I use all the three clouds. I don't use Alibaba, but other than that, I use all the three clouds, GCP, Azure, and AWS for different clients. So yes, whenever things goes down, things go crazy. People will be like behind your back and you can't do anything about it.
I think after this COVID, nobody wants to go to Alibaba, I believe.
Alibaba, you should never go. Even don't suggest that name also because I know their cases, they're not reliable.
Okay, guys, any questions to Shivang? Okay, looks like no. So Shivang, yeah, this was really a great session. If I have to compare this, because even I've been attending other trainings as well, what good I felt in this session is you never use PPT. So that was the best part. So generally what happens when with PPT, generally people come, read and go. But here, since you have used the dashboard, right, that was really helpful for everyone. In fact, even for me, I would try to um, follow your approach whenever I'm training someone.
Yeah, that I basically try to make it in a way like just like how we do face-to-face training. So generally there we use the whiteboards and all that. And that's basically there you can draw the free flow diagrams and all that. That's I've seen that basically helps. And most of these concepts, since I'm working from so many years now, these are just sitting on top of my mind. So that's the reason I don't use PPTs.
And what was that whiteboard that you used? Is it specific to only Mac, or do we get it even on Windows?
Which code?
The whiteboard that you are using, right? You are able to navigate between the pages.
That's a software called as Ink to Go.
Can you please type in the chat window?
So, sure. In your projects like you implement, like what do you usually use for scheduling the jobs or deploying them? Like, do you use any tools for that? What is your which would you prefer usually use?
basically you're asking how I schedule the jobs or not. There is something called as Uzi. This is what I use.
Can you say that again?
Uzi.
Okay.
Yeah. English, I just ping that.
Yeah, okay, thank you.
It's not free. It's actually a paid software. I have bought it long time back because I have to give presentations to my client. That's the reason I bought it. So because my clients are sitting in US and all, like for me, my meeting starts at morning 4 a.m. and that's how I used to join a call. Like 4 to 6 or 4 to 6:30, I used to join a call and then I go for a jog and come back and just sit in your sessions. That's how it used to be. So for all my clients, I use the same to go to kind of present something, whatever I want to.
So how different is Uzi from Airflow? Like I see a lot of requirements asking for Airflow. Like I was just curious, like how different they are, and
Airflow will make your life easier. It's paid. If you're using it from the cloud services, because though it's open source, but still you have to pay for it if you're using within cloud services. You can use Airflow also, which is also fine. But I prefer to go with Uzi because I became more habitual of this, to be frank, and it's easy for me to create pipelines through it. It's more like an XML thing when it comes to Uzi. With Airflow, you can also do a drag and drop. Kind of just say that, hey, I want to do this, then do this, then do this. You can create all those pipelines using that. So it's more easier, but it's again just a preference.
Okay.
Shivank, have you ever used Snowflake in any of your projects?
I did a POC on this, but then the client said that no, we don't want to.
But they say Snowflake is cheaper than S3, right? When it comes to storage.
Actually, found at lot many level, though the storage is cheaper, but there are a lot of many processing which went expensive. So overall bundle becomes sometimes expensive.
Okay.
This is a POC we did, and especially for that client application, it was becoming expensive. That's where we came back to Azure. So they preferred Azure after that.
Do you work with Azure a lot? Shiva?
I have worked with all the three clouds in fact.
Mhm.
So,
Have you worked with Synapse in Azure?
yeah, almost every component I might have used it. Now, since I have a team, it's little more easier because now I need not do too much of coding at least. Earlier, I used to even write every code on my own. But yes, it's every component I must have touched in all these cloud systems.
So Shivank, what kind of projects that you currently work on? Is it like data lakes or data warehouse projects or data science projects? Or is it like
I
a combination of everything?
made, yeah, it's a combination sort of like majorly we take up the projects in the AI field or related to this big data domain. So these are the two major domains what we pick up, which basically we have expertise in as well.
So what would be a good way to like reach you, like, email or something if you have questions or something, to get in touch with you?
Send you my mail ID. It's just that just please expect a little delay in response, maybe by a day or something, because I don't get time to kind of check my emails very frequently because I'm mostly into some of the other calls. But yes, within a day, like 24 hours, you will receive a response.
Okay, thanks, Sean.
Okay. Any other question?
So yeah, Shivank, I had this discussion internally, and I heard that you are occupied this Sunday. So we will get back to you in case if we need training on that Kafka. So we can go in depth and we can maybe talk more related to Kafka.
Sure.
We'll let you know.
Yes, in fact, for this whole 1 week, I'm little occupied. Yeah, after that we can start talking
Okay.
about.
Okay.
Sure. I think then this is it. Again, thank you everyone for listening me so patiently throughout all this 40 hours. Now it's all on you to go back, practice, and start implementing in your code. Do well in your projects. That will make your learning even much more better. And I again wish best of luck to all of you. Thank you, everyone.
Thank you, Shivank.
Sure.
Thank you, Shivam.
Yes,
Thank you very much.
Thank you, Shivam.
Thanks, Shivank.